Imagine discovering something that shouldn't exist, not because it's hidden, but because it doesn't fit anywhere in the story we've been told. No clear origin, no logical explanation, just fragments, precise, deliberate, and strangely familiar. Ancient traces that feel less like inventions and more like reminders, as if someone long ago understood something we no longer do. The deeper we look, the more unsettling the pattern becomes, knowledge appearing too early, designs repeating across time, and ideas that seem to echo forward rather than backward. It raises a possibility few are willing to consider. What if the past isn't behind us at all, but something we are slowly rediscovering, piece by piece? Rising from the desert plateau on the edge of the Nile Valley, the Great Pyramid of Giza remains one of the most extraordinary achievements of the ancient world and perhaps the most enduring architectural mystery ever created by human hands. Built more than 4,500 years ago, during the reign of the pharaoh Khufu of the 4th dynasty of Egypt, this immense stone monument once stood about 146 meters tall and for nearly 4,000 years remained the tallest structure ever built by humanity. Even today, after thousands of years of erosion and the loss of its gleaming outer casing stones, the pyramid still dominates the Giza plateau with an overwhelming sense of scale, balance, and precision. And yet what truly sets this monument apart from every other ancient structure is not only its enormous size or its historical importance, but the astonishing level of technical sophistication embedded within its design. At the heart of the mystery lies a feature that continues to fascinate engineers, archaeologists, and astronomers alike: the almost impossibly accurate orientation of the pyramid to the 4 cardinal directions of the Earth. Each side of the structure is aligned almost perfectly toward north, south, east, and west. Measurements conducted by modern surveyors have shown that the deviation from true north is only a few arc-minutes, a margin of error so small that even many contemporary buildings constructed with modern instruments struggle to match it. Achieving such accuracy today normally requires precision surveying equipment, astronomical instruments, and detailed geodetic calculations. Yet the builders of the Great Pyramid accomplished this feat more than 4,000 years ago, using tools that, according to current archaeological understanding, were limited primarily to stone implements, copper tools, ropes, wooden measuring rods, and simple sighting devices. The ancient Egyptians had no magnetic compass, no telescopes, no precision optics, and certainly no satellite-based navigation systems. Nevertheless, they managed to orient the largest stone monument of the ancient world with remarkable precision to the geometry of the planet itself. This extraordinary alignment raises one of the most compelling questions in ancient engineering. How did the pyramid's builders determine true north with such accuracy in a time when the technological means to do so appear extremely limited? Scholars have proposed numerous theories over the decades. One of the most widely discussed explanations suggests that Egyptian astronomer priests carefully observed the movement of circumpolar stars, stars that never set below the horizon and instead circle the northern sky throughout the night. By tracking the moment when certain pairs of stars aligned vertically above the horizon, they may have been able to establish an extremely accurate north-south axis. Another hypothesis suggests that they used a method based on the shadow of a vertical pole during the course of a day, and plotting the arc of the sun's movement and determining cardinal directions through geometric intersections. Some researchers have even suggested that simultaneous observations of stars crossing the meridian could have allowed the builders to define true north with remarkable accuracy. Yet despite decades of research and experimental reconstructions, none of these theories completely explains the precision observed in the pyramid's orientation. The margin of error is so small that it suggests either an extraordinary mastery of observational astronomy or a surveying method that remains only partially understood today. The significance of this alignment may not have been purely technical. In ancient Egyptian cosmology, order and balance were fundamental concepts, represented by the principle of Ma'at, the divine harmony governing the universe. Aligning the pyramid precisely with the cardinal directions may therefore have symbolized the pharaoh's role in maintaining cosmic order. By constructing his eternal monument in perfect harmony with the geometry of the earth and the movement of the heavens, the builders may have been creating not only a tomb, but a cosmic structure designed to connect the king with the eternal cycles of the universe. Surrounding this central mystery of orientation are other remarkable engineering achievements that further deepen the enigma of the Great Pyramid. The structure is composed of roughly 2,300,000 limestone and granite blocks, most weighing between 2 and 3 tons, with some granite beams exceeding 70 tons in weight. These stones were quarried from multiple locations, including massive granite blocks transported from the region of Aswan, located hundreds of kilometers to the south. Moving such enormous stones across vast desert landscapes and then lifting them to heights exceeding 100 meters remains one of the greatest logistical puzzles in ancient construction. Various theories involving massive earthen ramps, spiral ramp systems, sledges pulled over lubricated sand, and complex lever mechanisms have been proposed, yet no single model has been able to reproduce the entire construction process in a way that fully satisfies both the archaeological evidence and the time constraints believed to have existed. The precision with which the stones were cut and fitted adds another layer to the puzzle. Yet many of the blocks inside the pyramid are joined so tightly that the gaps between them measure only fractions of a centimeter. The original outer casing stones, made from fine white limestone, were polished to an extraordinary degree of smoothness and formed a perfectly flat surface that reflected sunlight brilliantly across the desert. Achieving such fine tolerances with copper chisels and stone hammers seems almost impossible by modern expectations of ancient technology. Inside the pyramid, the architectural sophistication becomes even more striking. Rather than being a simple solid structure, the pyramid contains a carefully designed system of corridors and chambers that reveal a deep understanding of structural stability and spatial planning. The ascending passage leads into the magnificent Grand Gallery, near a tall and steep corridor whose walls rise in a corbelled arrangement that distributes the immense weight of the masonry above it. At the heart of the pyramid lies the king's chamber, constructed entirely of massive granite blocks, fitted with astonishing precision. Above this chamber are several hidden relieving chambers designed to redirect the crushing pressure of the pyramid's upper layers, preventing the roof from collapsing under the weight of millions of tons of stone. Narrow shafts extend from the interior chambers toward the outer surface of the pyramid. Although they were once believed to function as ventilation shafts, their orientation toward specific regions of the sky has led many researchers to propose that they held symbolic or astronomical significance. And some of these shafts appear to align with stars associated with the constellation Orion, which in ancient Egyptian mythology was linked to the god Osiris and the idea of rebirth in the afterlife. If this interpretation is correct, the pyramid may have been designed as a monumental gateway between the earthly realm and the celestial world. When all of these elements are considered together, the near-perfect cardinal alignment, the massive transport of millions of stone blocks, the precision of the masonry, the complex internal structure, and the possible astronomical symbolism. The Great Pyramid appears not just as a tomb, but as one of the most remarkable engineering achievements of the ancient world. Even after centuries of research and modern technological analysis, and many aspects of its design and construction remain only partially understood. More than 4,000 years after it was built, the Great Pyramid of Giza continues to challenge our understanding of ancient technology and stands as one of humanity's greatest architectural mysteries. Where are you watching this video from, and what time of day is it for you? Share your location and time in the comments below. The Ggantija megalithic temples stand on the island of Gozo in the Mediterranean nation of Malta, rising from the rocky landscape like the remains of a civilization that time has almost erased. At first glance, the complex appears to be a cluster of ancient stone ruins, but closer inspection reveals something far more extraordinary. Archaeologists date the construction of Ggantija to roughly 3,600 to 3,200 BCE, making it one of the oldest freestanding stone monuments on Earth. In fact, the temples were already standing long before the famous stones of Stonehenge were erected and even before the construction of the early pyramids at Great Pyramid of Giza. Their age alone places them among the most remarkable achievements of prehistoric humanity. Yet the deeper mystery lies not only in when they were built, but in how and by whom. The name Ggantija itself reflects the astonishment these temples have inspired for centuries. In Maltese folklore, the word derives from Ggant, meaning giant, and local legends once claimed that only giants could have lifted the enormous stones used to construct the temples. The myth may sound fanciful, but it captures a very real question that continues to challenge archaeologists. The outer walls of the temples are built from enormous limestone blocks, some weighing over 50 tons and rising several meters high. These stones were quarried locally, yet even transporting them across short distances would have been an immense undertaking for a prehistoric society that possessed neither metal tools nor wheeled vehicles. At the time these temples were constructed, the inhabitants of the Maltese islands were living in what archaeologists classify as the late Neolithic period. Their tools were primarily made of stone, bone, and wood. There is no clear evidence that they possessed draft animals capable of pulling massive loads. Despite these limitations, the builders of Ggantija managed to move, shape, and precisely position stones of astonishing size. Equally remarkable is the way these stones were assembled. The temple walls are constructed using massive megaliths arranged in carefully balanced layers, forming curved facades and thick structural boundaries that have endured for more than 5,000 years. The stones fit together with surprising precision, despite the absence of mortar. In some places, the blocks align so closely that only the thinnest gap remains between them. The outer walls reach impressive thickness, creating a stable structure capable of resisting both time and seismic disturbances. This dry stone construction technique required not only physical labor, but also a deep understanding of balance, weight distribution, and structural geometry. For a prehistoric society working with limited tools, the level of engineering involved is difficult to underestimate. Inside the complex, the architectural layout reveals even more sophistication. The Ggantija complex actually consists of two adjoining temples built side by side. Each temple follows a distinctive plan centered around a main corridor leading to a series of semicircular chambers arranged in a trefoil pattern. and these spaces may have served ritual or ceremonial functions. Archaeologists have discovered stone altars, fragments of decorated pottery, and figurines believed to represent fertility goddesses, suggesting that the temples were important religious centers. The arrangement of chambers, entrances, and internal features demonstrates careful planning rather than random construction. The builders clearly followed an established architectural tradition, indicating that temple construction in Malta was part of a broader cultural system that extended across the islands. Another intriguing possibility is that the orientation of the temples may have been connected to astronomical observations. Some researchers believe that certain entrances and interior axes align with the rising position of the sun during specific times of the year. And if this interpretation is correct, the temple builders were not only skilled engineers, but also observers of the sky who incorporated celestial cycles into their sacred architecture. Across the ancient world, from Egypt to Mesoamerica, monuments were often aligned with astronomical events. But the presence of such knowledge in a Neolithic island culture raises important questions about the intellectual development of these early societies. Yet perhaps the greatest mystery surrounding Ggantija is not the stones themselves, but the people who built them. Despite the scale and complexity of these temples, the civilization responsible for constructing them remains largely unknown. Archaeologists refer to them simply as the prehistoric temple builders of Malta, but their language, social organization, and belief systems remain mostly speculative. Unlike later civilizations, they left behind no written records to explain their history or their achievements. What survives are only fragments of material culture: pottery shards, stone tools, figurines, and the temples themselves. From these clues, researchers attempt to reconstruct a vanished society that once flourished in the Maltese archipelago. This civilization appears to have been remarkably capable for its time. Building monuments on the scale of Ggantija would have required organized labor, skilled craftsmanship, and shared religious traditions strong enough to motivate entire communities to participate in construction. The temples were not simple shelters or defensive structures, but ceremonial spaces likely associated with ritual gatherings, seasonal events, and communal identity. Their builders possessed knowledge of quarrying, transportation, architectural design, and possibly astronomy. Such achievements suggest a society that was socially coordinated and culturally sophisticated, yet the historical record remains frustratingly silent about who these people were and how their culture functioned. Even more puzzling is what happened to them. Around 2500 BCE, the temple-building culture of Malta suddenly disappeared. Archaeological layers show a clear break between the temple period and later phases of settlement on the islands. For reasons that remain unclear, the society capable of constructing massive megalithic temples vanished from the archaeological record. Some researchers have proposed environmental explanations, such as deforestation, soil depletion, and/or climate change that may have made agriculture increasingly difficult on the small islands. Others suggest that disease, social collapse, or migration may have played a role. Yet none of these hypotheses fully explains the abrupt end of a culture that had thrived for centuries. Today, the ruins of Ggantija megalithic temples stand as silent witnesses to a lost prehistoric world. Their massive stones still dominate the landscape of Gozo, weathered yet enduring, representing one of the earliest examples of monumental architecture ever built by humans. The temples are part of the wider complex, known as the Megalithic Temples of Malta, a group of ancient structures that reveal an extraordinary prehistoric culture. Yet despite decades of archaeological research, many questions remain unanswered. How did a small island society organize the labor needed to construct monuments of such scale? What beliefs inspired them to devote generations to building these temples? And perhaps most mysterious of all, why did the civilization that created them disappear so completely from history? Today, the stones of Ggantija still stand, but the voices of the people who built them have long vanished, leaving behind one of the most enduring mysteries of the prehistoric world. What do you think really happened to the mysterious civilization that built Ggantija more than 5,000 years ago? Share your thoughts or theories in the comments below. The Stonehenge megalithic circle stands on the open grasslands of southern England's Salisbury Plain, a silent monument that has fascinated historians, archaeologists, and engineers for centuries. At first glance, it appears to be a simple arrangement of massive stones placed in a circular pattern, yet the deeper scientists study it, the clearer it becomes that Stonehenge is far more than a prehistoric stone ring. Built roughly between 3000 and 2500 BCE during the late Neolithic and early Bronze Age, the monument represents one of the most remarkable achievements of prehistoric engineering in Europe. But what makes Stonehenge truly extraordinary is not only the scale of its construction, but the precision and knowledge embedded within its design. Knowledge that raises profound questions about how ancient societies understood astronomy, geometry, and large-scale construction long before the emergence of written science. Among all the mysteries surrounding the monument, the most striking is its astonishingly precise astronomical alignment, a feature that continues to puzzle researchers and suggests that the builders possessed an advanced awareness of celestial movements. Standing at the center of the monument during the summer solstice reveals the most famous demonstration of this alignment. As the sun rises on the longest day of the year, its first rays appear directly above a solitary stone, positioned outside the main circle, known today as the heel stone. The sunlight travels along the central axis of the monument and shines directly into the heart of the stone arrangement, creating a dramatic visual event that still draws thousands of observers every year. The accuracy of this alignment is so precise that it cannot reasonably be dismissed as coincidence. The builders intentionally oriented the entire structure toward this point on the horizon, demonstrating a clear understanding of the annual solar cycle. Achieving such accuracy would have required long-term observation of the sun's movements across the landscape, careful measurement of the horizon, and the ability to translate that astronomical knowledge into a permanent architectural form. What remains unclear, however, is how a society without telescopes, metal precision instruments, and/or written mathematical systems managed to accomplish such a feat with such reliability. Some researchers believe that Stonehenge functioned as a form of prehistoric astronomical calendar, marking important seasonal events that were critical for agricultural societies. The summer solstice sunrise is the most dramatic alignment, but the monument also appears to correspond with the sunset of the winter solstice when viewed from another point within the complex. This dual alignment suggests a deliberate design linking both ends of the solar year. Other scholars have proposed that the arrangement of surrounding pits, known as the Aubrey holes, might even have been used to track longer astronomical cycles, including lunar phases or eclipses. While these interpretations remain debated, might they highlight an extraordinary possibility that the people who constructed Stonehenge possessed a sophisticated observational tradition capable of tracking complex celestial patterns across generations. Yet astronomy is only one piece of the puzzle. The stones themselves represent another technological challenge that continues to amaze modern engineers. The largest stones, known as sarsens, weigh up to 30 tons and were likely transported from quarries located roughly 25 kilometers away. Even more mysterious are the smaller bluestones, which originate from the Preseli Hills in Wales, over 200 kilometers from the site. Transporting these stones across rivers, hills, and forests without wheeled vehicles or metal tools remains one of the greatest logistical mysteries of prehistoric Europe. Various experiments have shown that teams of people using wooden sledges and rollers might have moved the stones gradually across the landscape, but the scale of coordination required for such an effort implies a highly organized society capable of mobilizing large numbers of workers over long periods of time. The engineering sophistication of Stonehenge becomes even more evident when examining how the stones were assembled. Rather than simply stacking them, the builders shaped the massive blocks with surprising precision. The horizontal lintel stones that sit atop the vertical pillars were carefully carved to form curved edges so that together they created a continuous circular ring. Even more remarkable is the use of joinery techniques that resemble woodworking methods. The vertical stones were carved with protruding tenons that fit into matching mortise holes in the lintels above them, effectively locking the stones together. In addition, the lintels were joined to each other using tongue and groove connections, ensuring that the circular structure remained stable. These techniques reveal a deep understanding of structural stability and stone shaping, achieved using tools that were likely made primarily of stone and early metals. Another mystery lies in the geometric layout of the monument itself. Stonehenge was not constructed randomly, but according to a carefully planned arrangement of circles, horseshoe shapes, and radial alignments. The spacing of stones suggests that the builders possessed a practical knowledge of geometry and surveying. Some researchers argue that ropes, wooden stakes, and simple measuring systems could have been used to establish accurate circular layouts. Even with such methods, however, the precision visible in the monument suggests an extraordinary level of planning and coordination. The project did not appear overnight. Archaeological evidence indicates that the site evolved through several phases of construction spanning nearly 15 centuries. Different groups of builders modified and expanded the monument over time, gradually transforming a simple earthwork enclosure into the complex megalithic structure visible today. The endurance of Stonehenge across more than 4,000 years also raises questions about the engineering choices made by its creators. The sarsen stones are exceptionally durable, and their deep foundations help stabilize them against wind and weather. Or the Trilithon structures, two upright stones supporting a horizontal lintel, distribute weight in a way that has allowed many of them to remain standing despite millennia of erosion and human interference. This durability suggests that the builders carefully selected both the materials and the structural design to ensure long-term stability. Despite centuries of research, the ultimate purpose of Stonehenge remains uncertain. Some archaeologists believe it served primarily as a ceremonial center connected to solar worship or seasonal rituals. Others suggest it functioned as a burial site or a place where communities gathered to honor ancestors. There is also evidence that people traveled great distances to reach the monument, hinting that it may have been a significant pilgrimage destination within the ancient landscape of Britain. Or whatever its purpose, the combination of astronomical precision, massive engineering effort, and symbolic significance makes Stonehenge one of the most enigmatic monuments ever constructed by prehistoric humans. Today, as the sun rises over the Salisbury Plain and once again aligns perfectly with the ancient stones during the summer solstice, the monument continues to demonstrate the extraordinary capabilities of its builders. Long before written history recorded scientific knowledge, the creators of Stonehenge appear to have carefully studied the sky, measured the landscape, and transformed their observations into a structure that has endured for thousands of years. In doing so, they left behind not only a monument of stone, but also a profound mystery: how a prehistoric society achieved such a precise fusion of astronomy, in geometry, and engineering without the technological tools we consider essential today. What do you think? How did ancient builders manage to align Stonehenge with the sun so precisely more than 4,000 years ago? Share your thoughts in the comments below. Rising from the rose-colored desert cliffs of southern Jordan, Petra rock-cut city stands as one of the most extraordinary archaeological sites ever discovered. Hidden for centuries within a labyrinth of sandstone mountains, the ancient city was once the thriving capital of the Nabatean kingdom, a civilization of desert traders who controlled vast caravan routes linking Arabia, Egypt, and the Mediterranean world. When the Swiss explorer Johann Ludwig Burckhardt rediscovered Petra in 1812, he revealed to the outside world a place that seemed almost impossible, a city not built from stone blocks, but carved directly into the living mountains themselves. Today, even after more than 2 centuries of archaeological study, Petra continues to challenge modern understanding of ancient engineering and construction, and particularly because of the astonishing technique used to create its monumental architecture, an entire urban landscape sculpted straight into towering sandstone cliffs. The most striking and mysterious feature of Petra is the method by which its most famous structures were created. Unlike traditional cities, where buildings are assembled stone by stone, the monuments of Petra were carved directly into enormous vertical rock faces. Massive facades, towering columns, decorative pediments, and intricate relief carvings were not constructed separately and then attached. Instead, they were gradually sculpted out of the cliff itself. This means that every famous structure in Petra, including temples, royal tombs, ceremonial halls, and monumental gateways, once existed as part of a single, solid wall of stone. The builders did not bring stone to the site, they removed it. In effect, Petra's architecture was created through subtraction rather than construction, transforming raw geological formations into elaborate works of architectural art. One of the most iconic examples of this astonishing technique is the monumental facade known as Al-Kazne, often called the Treasury. Standing roughly 40 meters high and carved entirely from a sheer sandstone cliff, the structure displays an extraordinary level of symmetry, proportion, and decorative sophistication. Its columns, statues, and ornamental elements echo the architectural styles of the Hellenistic world, suggesting that the Nabateans were deeply connected to broader Mediterranean cultural influences. Yet the method by which this immense facade was created raises profound questions. Archaeological evidence strongly suggests that these structures were carved from the top downward. Ancient workers would begin at the uppermost part of the cliff and gradually cut downward, shaping the architecture as they descended. This technique would have required extraordinary planning, because any mistake made during the carving process could not be corrected. A single miscalculation in proportion or alignment could ruin the entire structure, yet the surviving monuments show remarkable geometric precision and symmetry. The challenge of carving architecture directly into cliffs of this scale is difficult to fully appreciate. Some of Petra's facades rise more than 40 meters high, and many are positioned on steep rock walls where natural ledges are minimal or non-existent. For workers to begin carving from the top, they must have had some system of scaffolding, ropes, platforms, or suspended working structures anchored to the rock above. However, the exact methods used remain unclear. Unlike wooden scaffolding in later historical structures, any temporary construction equipment used at Petra would likely have disappeared long ago, leaving few traces behind. As a result, archaeologists can only speculate about how Nabatean builders were able to safely position workers and tools across such vast vertical surfaces while maintaining precise architectural control. Equally mysterious are the tools used to perform the carving itself. Petra's sandstone is softer than granite or basalt, which makes it workable, but it is also fragile and prone to fracture if cut improperly. Creating smooth architectural lines, symmetrical columns, and detailed sculptural ornamentation would have required careful control over chisels and cutting techniques. The Nabateans likely used iron tools, but the consistency and scale of the carving suggest a highly organized and skilled workforce with advanced knowledge of stone behavior. The surfaces of many facades still preserve subtle carving marks, revealing that the work was done methodically in horizontal layers, gradually shaping the cliff into architectural form. Beyond the visual grandeur of its carved monuments, Petra also demonstrates remarkable engineering in another critical area: water management. The city lies in a desert region where rainfall is scarce and unpredictable, yet archaeological evidence indicates that Petra once supported a population of tens of thousands of people. The Nabateans developed an elaborate system of channels, reservoirs, dams, and ceramic pipes to capture and store water from seasonal rainfall and distant springs. Along the narrow canyon known as the Siq, the dramatic entrance passage into the city, carefully carved channels once carried water along the cliff walls, protecting the city from destructive flash floods while simultaneously supplying drinking water to its inhabitants. The precision of these channels suggests that Nabatean engineers carefully calculated the slope and flow rate to ensure efficient water movement without erosion. Despite its impressive technological achievements, Petra eventually declined. Earthquakes during late antiquity damaged parts of the city, and shifting trade routes reduced its economic importance. Over centuries, the once great metropolis faded from global awareness, remembered only by local Bedouin communities who continued to pass down knowledge of its hidden location. When Burckhardt rediscovered Petra in the early 19th century, the world was stunned by the scale and beauty of the forgotten stone city. Yet even today, Petra is far from fully understood. Modern satellite imagery and ground-penetrating surveys suggest that large portions of the ancient city remain buried beneath sand and rock debris. New discoveries continue to reveal previously unknown structures, indicating that Petra may have been far larger and more complex than archaeologists once believed. What remains most astonishing, however, is the central mystery that defines the site: the creation of a vast architectural landscape carved directly from mountain cliffs. The ability of an ancient desert civilization to sculpt monumental buildings out of sheer rock faces with such precision challenges modern assumptions about the technological limitations of the ancient world. Standing before the towering facades of Petra today, it becomes clear that this city represents far more than a simple archaeological site. The Nabateans transformed natural mountains into architecture, carving temples, tombs, and ceremonial spaces directly from solid cliffs. Yet the exact methods behind such precise and massive rock-cut construction remain only partially understood. Petra therefore remains one of the most remarkable examples of ancient engineering, reminding us that the technological abilities of ancient civilizations may still hold secrets modern science has yet to fully explain. In your opinion, and how were the ancient Nabateans able to carve an entire massive city directly into mountain cliffs with such astonishing precision? Share your thoughts or theories in the comments below. Rising from the ancient city of Baalbek, the massive stone platform known as the Baalbek Trilithon remains one of the most perplexing engineering enigmas of the ancient world. Forming part of the immense foundation beneath the monumental temple of Jupiter at Baalbek, the Trilithon consists of 3 colossal limestone blocks positioned high within the western retaining wall of the temple platform. Each of these stones measures roughly 20 meters in length, about 4 meters in height, and weighs close to 1,000 tons. To put that scale into perspective, a modern battle tank weighs around 60 to 70 tons, meaning a single Trilithon block is comparable in mass to more than a dozen tanks combined. Even with modern heavy lifting equipment, moving a stone of this magnitude is a formidable logistical challenge. Yet these stones were not simply dragged into place along the ground. They were carefully positioned several meters above the foundation level, forming part of a layered architectural structure whose precision and ambition continue to puzzle engineers and archaeologists alike. The mystery deepens when one considers the nearby quarry, located only a few hundred meters from the temple complex. Within this quarry lie several unfinished monoliths that dwarf even the Trilithon blocks themselves. Among them are the famous Stone of the Pregnant Woman and the massive Stone of the South, stones estimated to weigh well over 1,000 tons. More recently, excavations have revealed another even larger block, sometimes referred to as the Forgotten Stone, which may approach 1,600 tons. These enormous stones remain embedded in the bedrock, apparently abandoned before transport, suggesting that ancient builders were experimenting with stones of extraordinary size. The quarry therefore presents a fascinating paradox. If these larger stones proved too difficult to move, how were the slightly smaller, yet still staggering Trilithon blocks successfully transported and installed at the temple platform? Equally astonishing is the precision with which the Trilithon stones were cut and fitted. The surfaces of the blocks are remarkably flat, and the joints between them are so tight that even a thin blade can barely be inserted between the stones. No mortar holds them together. Their stability relies entirely on the precision of the stonework and the immense weight of the blocks themselves. This level of craftsmanship recalls other megalithic sites around the world, such as Sacsayhuamán or Pumapunku, where massive stones were shaped with extraordinary accuracy. Yet even in comparison to those sites, Baalbek stands apart because of the sheer scale involved. Cutting and shaping stones, weighing hundreds of tons with such precision, would already be a significant technological challenge. Doing so with stones approaching 1,000 tons raises questions about the tools, methods, and organizational capacity available to the builders. However, perhaps the greatest unresolved puzzle surrounding the Trilithon is not the cutting of the stones, but the problem of transportation. The quarry from which the stones originated lies roughly 800 meters away from the temple platform. On paper, this distance seems trivial, or for ordinary construction materials, it would represent little more than a short journey. But when dealing with monoliths approaching 1,000 tons, even moving them a few meters becomes a monumental undertaking. Modern engineers estimate that transporting a stone of this size across uneven terrain would require enormous mechanical advantage, carefully prepared ground, and a highly coordinated labor force. Ancient builders, however, appear to have accomplished this feat long before the invention of modern cranes, engines, or hydraulic systems. Several theories have been proposed to explain how these stones might have been moved, yet none have been definitively proven. One commonly suggested idea is that the stones were dragged on massive wooden sledges across a pathway lubricated with water or clay, possibly using logs as rollers beneath the sledges. In theory, thousands of laborers pulling ropes could generate the force necessary to move such weight. Yet experiments attempting to replicate similar methods have demonstrated that the friction involved with stones of this magnitude would be extreme, potentially requiring an impractically large workforce and highly stable ground conditions. Another hypothesis proposes the use of gigantic earthen ramps or inclined planes. According to this theory, builders may have gradually raised the stones along a slope built from compacted soil and rubble until the blocks reached the required height. However, archaeologists have found little physical evidence of such ramps surviving near the temple platform, and constructing ramps large enough to lift stones of this size would itself have been a massive engineering project. Other researchers speculate that more sophisticated mechanical systems may have been employed, possibly involving complex arrangements of ropes, pulleys, and counterweights. Ancient civilizations were certainly capable of impressive mechanical ingenuity, as demonstrated by lifting devices used in Greek and Roman construction. Yet even the most advanced lifting machinery known from antiquity appears insufficient to raise stones weighing close to 1,000 tons. For this reason, the precise method used to move the Trilithon stones remains one of the most debated topics in ancient engineering studies. No full-scale reconstruction has yet succeeded in demonstrating a definitive solution that convincingly explains how these monoliths were transported from quarry to platform and then lifted into their final position. Another intriguing detail adds to the mystery. In conventional architectural logic, the largest and heaviest stones are typically placed at the lowest level of a structure to provide stability. At Baalbek, however, the opposite arrangement appears to have been chosen. The Trilithon blocks sit high within the wall, above courses of smaller stones. This unusual configuration raises further questions about the intentions of the builders. Were these enormous blocks intended purely for structural support, or did they serve some symbolic or ceremonial purpose that justified the extraordinary effort required to place them there? The chronological origins of the Trilithon also remain uncertain. The grand temple complex visible at Baalbek today was largely constructed during the Roman period, beginning around the 1st century of the Common Era. Yet some scholars believe that the enormous foundation stones may predate the Roman structures and were incorporated into the later temple architecture. If this interpretation is correct, the Trilithon might represent the remnants of an earlier monumental platform built by a culture whose engineering methods are no longer fully understood. Whether constructed by Roman engineers, pushing the limits of ancient technology, or inherited from an earlier phase of construction, the Trilithon continues to challenge conventional assumptions about what ancient builders were capable of achieving. Today, the Baalbek Trilithon remains one of the most remarkable engineering mysteries of the ancient world. These massive stones stand as silent witnesses to a construction process lost to history. Even after centuries of research, key questions remain unanswered. How such enormous stones were cut with precision, how they were transported without modern machinery, and how they were lifted and fitted into a structure that still stands more than 2,000 years later. Until clear answers emerge, Baalbek continues to challenge our understanding of ancient technology. How do you think ancient builders managed to transport and position the nearly 1,000-ton stones at Baalbek without modern machinery? Share your thoughts or theories in the comments below. The Yonaguni Submerged Monument, located off the coast of Yonaguni Island in Japan's Okinawa Prefecture, is one of the most controversial and mysterious underwater structures ever discovered. Hidden beneath the waves of the Pacific Ocean, this enormous stone formation has sparked decades of debate among geologists, archaeologists, and historians. The structure was first brought to international attention in 1986 when local diver Kihachiro Arataki accidentally encountered it while searching for hammerhead sharks. What he found beneath the surface did not resemble a typical natural rock formation. Instead, he described a massive step structure rising from the seabed, with enormous terraces, sharp edges, and geometric shapes that seemed strangely deliberate. Since that discovery, the Yonaguni Monument has become the center of an ongoing scientific controversy. Is it a rare but natural geological formation? Or could it be the submerged remains of an ancient human-made structure lost beneath the sea? At first glance, the monument resembles a gigantic underwater pyramid carved directly into the bedrock. The main structure measures roughly 150 meters in length, around 40 meters in width, and about 25 meters in height. Divers exploring the site have documented a series of enormous terraces stacked in step-like formations, creating the impression of monumental stairways leading upward from the ocean floor. These terraces appear surprisingly flat and uniform, with edges that sometimes form angles approaching 90 degrees. In natural geological formations, an erosion typically produces irregular shapes and fractured surfaces. Yet many areas of the Yonaguni Monument appear unusually smooth and sharply defined. The steps themselves are immense, far larger than ordinary architectural staircases, and extend across large sections of the structure. Some researchers have noted that these tiers resemble the stepped pyramids found in ancient civilizations elsewhere in the world, although no direct cultural connection has ever been established. Another striking feature of the monument is the presence of long, straight edges and sharply cut-looking channels running across the rock surface. These lines can stretch for many meters, forming geometric patterns that seem difficult to attribute entirely to natural processes. In certain areas, the stone appears to form broad platforms bordered by vertical walls, creating spaces that resemble plazas or courtyards. Some divers have even described narrow corridors or pathways that give the impression of an organized layout, as though the formation might once have been part of a larger architectural complex. There have also been claims that some surfaces display shapes that resemble carvings or symbolic patterns, although these interpretations remain controversial and have not been universally accepted by scientists. Critics argue that such patterns may simply be the result of natural fracturing in sedimentary rock, while supporters of the artificial structure hypothesis believe they could represent traces of ancient human activity. Yet the most intriguing and scientifically challenging mystery surrounding the Yonaguni Monument is not simply its shape, but its age and its relationship to ancient sea levels. Today, the structure lies approximately 25 meters beneath the surface of the ocean. Geological studies of global sea level changes suggest that during the last ice age, large amounts of water were locked in continental ice sheets, causing ocean levels to be significantly lower than they are today. As the Ice Age ended roughly 10,000 years ago, glaciers began to melt, and the oceans gradually rose, flooding vast coastal regions around the world. If the Yonaguni structure was originally built on dry land before this dramatic rise in sea level, then the implications would be extraordinary. It would suggest that a sophisticated stone-building culture may have existed in this region more than 10,000 years ago, long before many of the earliest known monumental constructions of the ancient world. This possibility is what makes Yonaguni such a compelling puzzle. Most of the monumental architecture commonly associated with early civilizations, such as pyramids, temples, and large-scale stone complexes, appears in the archaeological record several thousand years later. For example, the famous pyramids of Egypt were constructed around 4,500 years ago, while other early stone monuments appeared in regions such as Mesopotamia and Mesoamerica thousands of years after that. If the Yonaguni Monument truly dates back to a period before the end of the last ice age, it would push the origins of advanced stone construction far deeper into prehistory than previously believed. Such a conclusion would challenge many established assumptions about when and where complex civilizations first emerged. However, the evidence remains deeply contested. Many geologists argue that the monument can be explained entirely by natural geological processes. The rock around Yonaguni is primarily sandstone and mudstone, materials that tend to fracture along straight plains. Over long periods of time, tectonic activity, underwater currents, and erosion can carve these fractured layers into shapes that appear geometric or artificial. According to this view, the terraces and steps of the monument are simply the exposed layers of sedimentary rock that have been shaped by natural forces over thousands of years. In contrast, other researchers, most notably marine geologist Masaki Kimura, have argued that while the base structure may be natural, certain features appear too symmetrical and organized to be explained purely by geology. Kimura has suggested that humans may have modified a natural rock formation, carving steps, platforms, and passages into the stone when the area was still above sea level. Despite decades of investigation, no definitive archaeological artifacts, such as tools, pottery, or human remains, have been discovered at the site to conclusively prove human construction. Without such evidence, the monument remains suspended between two competing interpretations. On one side stands the explanation of an extraordinary but natural geological formation, sculpted by tectonic forces and erosion, and on the other lies the possibility of a lost prehistoric structure that disappeared beneath rising seas thousands of years ago. The true answer may lie somewhere in between, but until further evidence emerges, the Yonaguni submerged monument continues to occupy a fascinating gray area between geology, archaeology, and mystery. Today, divers descending into the deep blue waters around Yonaguni still encounter the same massive terraces, sheer stone walls, and enormous steps that first astonished explorers decades ago. As sunlight filters through the water and reveals the geometric contours of the formation, it is easy to understand why some observers see the outlines of an ancient monument resting silently on the ocean floor. Whether it is a remarkable natural formation or the forgotten remnant of a lost civilization, the Yonaguni submerged monument remains one of the most intriguing underwater enigmas on Earth. An enduring reminder that vast chapters of humanity's past may still lie hidden beneath the oceans, waiting to be understood. Do you think the Yonaguni submerged monument is simply a rare natural rock formation? Or could it be the remains of an ancient civilization that was submerged by the ocean thousands of years ago? Share your thoughts in the comments below. Hidden behind the grand mortuary temple of Seti I at the ancient sacred city of Abydos lies one of the most unusual and enigmatic structures in Egypt. The Osireion. At first glance, it appears dramatically different from the ornate temples and monumental pylons that typically define Egyptian architecture. There are no towering decorated columns, no walls densely covered with hieroglyphs, and none of the elaborate artistic programs normally associated with royal construction. Instead, the Osireion presents something far more austere and mysterious, a massive subterranean complex built from colossal blocks of granite arranged in a stark and almost primitive geometric form. Yet this apparent simplicity hides a level of engineering sophistication that continues to puzzle archaeologists and engineers alike. Discovered and excavated in the early 20th century by British archaeologist Margaret Murray and later studied by Henri Frankfurt, the structure immediately raised questions about its origin, its purpose, and the techniques used to construct it. Although inscriptions nearby attribute the surrounding temple complex to Seti I of Egypt's 19th dynasty, many researchers have long suspected that the Osireion itself may be far older, perhaps even predating the temple that now stands beside it. The reason for this suspicion lies primarily in the building's unique architectural style. Unlike most Egyptian temples, which were constructed using sandstone or limestone blocks of manageable size, the Osireion relies on enormous megalithic granite stones, some estimated to weigh between 70 and 100 tons. These massive blocks form thick walls surrounding a central island-like platform that is encircled by a water-filled trench, creating an atmosphere that feels less like a traditional temple and more like a symbolic landscape of primordial creation. What makes the Osireion particularly fascinating, however, is not simply the size of its stones, but the extraordinary precision with which those stones were shaped and assembled. Granite is among the hardest natural stones used in ancient construction, significantly more difficult to cut than limestone or sandstone. According to conventional historical understanding, Egyptian builders primarily used copper tools, stone pounders, and abrasive sand to shape stone during the New Kingdom period. While such methods are effective for softer materials, the level of precision visible in the Osireion's granite blocks raises serious questions about how these techniques alone could have achieved such results. The surfaces of many blocks appear strikingly flat, with edges that meet at sharp and nearly perfect right angles. In several areas, the stones fit together so tightly that even thin blades cannot easily be inserted between them. The joints show almost no visible gaps, suggesting a degree of planning, measurement, and craftsmanship that would have required exceptional skill and possibly more advanced methods than are usually attributed to the time. Some stones appear to have been shaped in such a way that they interlock with neighboring blocks, distributing weight evenly and creating a stable structure capable of supporting tremendous loads. When standing inside the Osireion, the impression is overwhelming. Enormous stones, each carefully cut and aligned, forming a structure that has endured for thousands of years, despite water infiltration, earthquakes, and the passage of time. This precision becomes even more astonishing when considering the scale involved. Cutting small stones with accuracy is one challenge. Cutting blocks weighing dozens of tons to such exact specifications is another entirely. Equally puzzling is the question of how these massive granite stones were transported to the site in the first place. Geological evidence suggests that the granite used in the Osireion originated from quarries near Aswan, located roughly 150 kilometers to the south along the Nile River. And quarrying granite blocks of such size would have required enormous labor and highly organized logistical planning. After extraction, the stones would have needed to be transported downriver, unloaded, and then moved across land to the construction site at Abydos. Yet the Osireion presents an additional complication. Much of the structure sits below ground level. This implies that builders either excavated a deep pit before placing the stones or lowered the massive blocks into position within an already prepared subterranean chamber. Either scenario raises formidable engineering challenges. Lowering stones weighing tens of tons into a confined underground space would have required carefully designed ramps, scaffolding systems, or lifting mechanisms. Although ancient Egyptians were certainly capable engineers, knew the exact methods used to position these enormous granite blocks with such precision remain largely speculative. The unusual layout of the Osireion further deepens the mystery. At its center lies a raised rectangular platform, often referred to as an island, surrounded by a water channel that fills naturally from the groundwater table of the Nile floodplain. Some Egyptologists interpret this arrangement as a symbolic representation of the ancient Egyptian creation myth, in which the first land rose from the primordial waters of chaos. In this interpretation, the Osireion may have been designed as a ritual landscape associated with the god Osiris, the deity of death, rebirth, and the afterlife, whose cult was particularly strong in Abydos. The surrounding water may have represented the cosmic ocean known as Nun, and while the central platform symbolized the first mound of creation emerging from those waters. Yet even this symbolic explanation does not fully address the engineering sophistication evident in the construction. The alignment of the stone blocks, the scale of the granite elements, and the overall geometric clarity of the structure suggest careful architectural planning, far beyond what might be expected for a purely symbolic installation. Another intriguing aspect of the Osireion is how strongly it resembles megalithic architecture found in other parts of the ancient world. The use of enormous precisely cut stones evokes comparisons with sites such as Sacsayhuamán in Peru or Pumapunku in Bolivia, where massive blocks were also cut with remarkable precision and fitted together with minimal gaps. But while there is no direct evidence linking these cultures, the similarities raise fascinating questions about whether ancient civilizations independently developed comparable techniques for working with large stones, or whether there may have been broader traditions of megalithic engineering that we do not yet fully understand. The Osireion's stark, almost monumental simplicity contrasts sharply with the elaborate decorative style typical of Egyptian temples, further fueling speculation that it may represent an architectural tradition older than the surrounding structures attributed to Seti I. Today, the Osireion remains partially submerged due to high groundwater levels, adding to its mysterious atmosphere. Visitors often see massive granite pillars rising from still water, reflecting a striking image of ancient engineering beneath the desert surface. Despite more than a century of research, many questions remain unanswered. How were the enormous granite blocks cut with such precision? What tools allowed ancient builders to shape such hard stone so accurately? And was the Osireion truly built during the reign of Seti I, or could it be part of a much older architectural tradition lost to time? Even today, the structure continues to challenge our understanding of ancient engineering. Do you believe the enormous granite blocks here were truly cut and fitted with such precision using only ancient tools, or could there have been a more advanced construction technique that we still do not fully understand? Share your thoughts in the comments below. The Great Zimbabwe Stone. Enclosure in present-day Zimbabwe stands as one of the most remarkable and enigmatic architectural achievements of ancient Africa. Hidden among granite hills and open savanna, The ruins form the heart of a vast stone-built city that flourished between the 11th and 15th centuries. At its peak, Great Zimbabwe served as the political and economic center of a powerful kingdom connected to long-distance trade networks stretching across the Indian Ocean. Archaeological evidence suggests that gold, ivory, and other valuable goods flowed through this city toward trading ports on the East African coast, linking the region to merchants from Arabia, Persia, India, and even China. Yet while the prosperity and influence of Great Zimbabwe are increasingly understood, much of the methods used to construct its monumental architecture and the circumstances surrounding its mysterious abandonment remain among the most intriguing puzzles in African archaeology. The most iconic structure within the complex is the Great Enclosure, an enormous circular stone wall that represents the largest ancient structure south of the Sahara Desert. The enclosure is astonishing in both scale and craftsmanship. Its outer wall rises to heights of around 11 meters and can reach more than 5 meters in thickness, forming an elegant curved barrier that stretches roughly 250 meters in circumference. What makes this construction especially extraordinary is that the wall was built entirely without mortar. Instead of using binding materials, builders carefully shaped and stacked hundreds of thousands of granite blocks in precise horizontal layers, relying solely on gravity and friction to maintain stability. The stones fit together with such accuracy that many sections of the wall have remained intact for more than 6 centuries, despite earthquakes, erosion, and seasonal rains. Even modern engineers often remark that constructing such large, curved, dry stone walls requires a deep understanding of structural balance and weight distribution. How the builders of Great Zimbabwe achieved such precision without advanced metal tools or written engineering plans remains a topic of debate among researchers. The granite used to build the enclosure was quarried from the surrounding hills, where natural outcrops provided raw material for construction. Ancient workers appear to have heated sections of rock with fire and then cooled them rapidly with water to fracture the granite into manageable blocks. These pieces were then trimmed and arranged into remarkably consistent shapes before being transported to the construction sites. Archaeologists estimate that close to 1 million stones may have been used across the broader complex. Moving and placing such a vast quantity of material would have required an organized labor force and sophisticated logistical planning. Yet no written records describing these processes have ever been discovered. Unlike many civilizations that left behind architectural manuals or inscriptions commemorating construction projects, the society that built Great Zimbabwe communicated its knowledge primarily through oral traditions. As a result, modern scholars are left to reconstruct the engineering methods through fragments of physical evidence alone. Inside the Great Enclosure stands one of the most puzzling features of the site, the conical tower, a solid stone structure rising roughly 9 meters high. Unlike most towers, it contains no internal chamber, no entrance, and no stairway. It is essentially a massive stone cone, built with the same dry stone technique used in the surrounding walls. Its purpose remains uncertain. Some researchers believe the tower symbolized royal authority or fertility, possibly representing a traditional grain storage structure that symbolized prosperity and abundance. Others think it may have played a role in ritual ceremonies associated with leadership or sacred power. Without written explanations from the builders themselves, just the conical tower continues to provoke speculation about the symbolic and cultural meanings embedded within the architecture of Great Zimbabwe. Beyond its monumental structures, the broader city reveals signs of careful urban planning. The ruins are generally divided into 3 main zones: the hill complex, perched on a granite ridge, the Great Enclosure in the valley below, and a sprawling network of residential areas spread across the surrounding plains. Narrow stone passageways, terraces, and walls create controlled routes between these areas, suggesting that movement through the city may have been organized according to social rank or ceremonial function. Archaeologists believe the hill complex may have served as an early royal residence or religious center, or while the Great Enclosure may have been associated with elite families or royal ceremonies. Decorative stone patterns woven into some walls, zigzag bands, and geometric motifs formed by carefully arranged stones demonstrate that the builders were concerned not only with stability, but also with aesthetic symbolism. These design elements suggest a sophisticated architectural tradition that blended engineering skill with cultural expression. Yet for all its impressive achievements, the story of Great Zimbabwe contains one of archaeology's most haunting mysteries: its sudden decline and abandonment during the 15th century. For centuries, the city had been a thriving hub of trade and political authority, controlling regional commerce in gold and ivory and supporting a population that may have reached tens of thousands. Then, and gradually but decisively, the city was deserted. By the time Portuguese explorers reached the East African coast in the early 16th century, the once powerful capital was already fading into legend. The reasons for this dramatic collapse remain uncertain, and scholars continue to debate several possible explanations. One theory suggests environmental pressure played a crucial role. A large urban population would have required vast amounts of wood for construction, cooking, and metalworking, potentially leading to deforestation in the surrounding landscape. Overgrazing by cattle and intensive farming may have also degraded the soil, making agriculture increasingly difficult. As resources became scarce, sustaining a large city in that environment may have become impossible. Another hypothesis focuses on shifts in regional trade networks. Great Zimbabwe's prosperity depended heavily on long-distance commerce, with coastal trading ports connected to the Indian Ocean world. If those trade routes changed, perhaps favoring new inland centers or different coastal cities, the economic foundation of the kingdom may have weakened. Some historians believe political power gradually shifted northward to other states such as the Kingdom of Mutapa, drawing population and influence away from Great Zimbabwe. Climate change may also have played a role. Evidence from environmental studies suggests that parts of southern Africa experienced periods of drought during the late medieval period. Even relatively small changes in rainfall could have had dramatic effects on agriculture, livestock, and water supply, forcing communities to relocate in search of more sustainable land. However, no single explanation fully accounts for the scale and speed of the city's abandonment. What makes the mystery particularly compelling is the absence of clear signs of catastrophe. There is little archaeological evidence of large-scale warfare, destruction, or natural disaster at the site. Instead, Great Zimbabwe appears to have been gradually left behind, its stone walls standing silently as the population moved elsewhere. Over time, vegetation reclaimed the surrounding valley, and the once thriving capital faded from living memory. When European travelers eventually encountered the ruins centuries later, they struggled to believe that such monumental architecture could have been built by African societies, and leading to misguided colonial myths about foreign builders. Modern archaeology has firmly demonstrated that Great Zimbabwe was the product of a highly sophisticated local civilization whose achievements rival those of many contemporary cultures around the world. Today, the Great Zimbabwe Stone Enclosure remains an important symbol of African heritage and a reminder that much of human history is still not fully understood. Its massive dry stone walls reveal the remarkable engineering skill and organizational ability of its builders, while the mysterious conical tower hints at cultural meanings that have yet to be fully explained. Yet the greatest mystery may not be how the city was built, but why it was abandoned. A once powerful center of trade and authority gradually disappeared, and leaving behind stone walls that continue to puzzle archaeologists to this day. What do you think truly caused a powerful city like Great Zimbabwe to be abandoned almost silently? Share your thoughts or theories in the comments below. On the remote volcanic landscape of Easter Island, best known for its enigmatic Moai statues staring silently across the Pacific, stands a structure that quietly challenges many assumptions about the technological capabilities of the ancient Polynesian world. This structure is Ahu Vinapu, a megalithic ceremonial platform whose construction techniques appear strikingly different from most other architectural remains on the island. While the Moai themselves dominate the global imagination, Vinapu has captured the attention of archaeologists and historians for a different reason: the extraordinary precision of its stonework. Unlike the majority of Ahu platforms across Rapa Nui, which were built from roughly stacked stones and irregular blocks, the walls of Vinapu display a level of refinement and precision that seems unexpectedly sophisticated for a society that possessed neither metal tools nor complex mechanical technology. The stones are carefully shaped, their faces smoothed, and their edges aligned with a precision that has often been compared to the famous stone masonry of the Inca civilization in South America. This resemblance has fueled decades of debate and speculation, raising questions about whether such construction techniques emerged independently on opposite sides of the Pacific, or whether some form of ancient cultural interaction may once have linked these distant worlds. Among all the mysteries surrounding Ahu Vinapu, perhaps the most intriguing concerns the remarkable flatness of the massive stone blocks used in its construction. Many of the stones forming the platform's retaining walls possess surfaces that appear almost perfectly planar, as though they had been carefully ground down and polished using methods far more advanced than what archaeologists typically associate with early Polynesian technology. These blocks are not merely rough volcanic stones stacked upon one another. Instead, they show signs of deliberate shaping, with surfaces that meet one another in such tight contact that gaps between them are almost non-existent. In some areas, the stones fit together with such precision that even a thin blade could barely be inserted between them. Achieving this level of smoothness and accuracy is difficult even with modern stone-cutting equipment, which makes the methods used by the ancient builders of Vinapu especially puzzling. The inhabitants of Rapa Nui are known to have relied primarily on tools made from basalt, obsidian, and other types of volcanic stone. While such tools can indeed be used to shape rock through repeated hammering, grinding, and abrasion, producing large, perfectly flat surfaces across multi-ton blocks would require immense labor, careful planning, and highly refined techniques that archaeologists are still attempting to fully understand. The mystery deepens when one considers the size and weight of the stones involved. Some blocks within the Vinapu platform weigh several tons, yet they were not only transported across the island, but also positioned with remarkable precision to form a structurally stable wall. The process of extracting these stones from local quarries, shaping them with simple tools, and transporting them across uneven terrain, and then aligning them with such accuracy would have required a level of coordination and engineering knowledge that remains difficult to reconstruct today. Even more fascinating is the fact that the stones were shaped in ways that allowed them to lock together naturally, distributing weight evenly across the structure. This technique ensured that the wall remained stable without the use of mortar, relying instead on gravity and precision fitting. Similar construction principles can be observed in the stone walls of Sacsayhuamán and the terraces of Machu Picchu, where polygonal masonry allowed structures to withstand earthquakes for centuries. Yet the presence of comparable masonry on a small Polynesian island thousands of kilometers away introduces a fascinating puzzle. Was this resemblance purely coincidental, or does it hint at technological ideas spreading across the Pacific long before European exploration? What makes Vinapu even more unusual is that its construction style does not appear widely elsewhere on Easter Island. Most Ahu platforms were built using irregular stones stacked together in a comparatively simple manner, suggesting that Vinapu may represent either a specialized architectural tradition or a structure built under unique circumstances. Some archaeologists believe it may have been one of the earliest ceremonial platforms on the island, possibly constructed during a period when different building techniques were being experimented with. None others suggest that it may have held particular religious or political significance, prompting its builders to employ unusually meticulous craftsmanship. Excavations around the site have revealed evidence of ceremonial activity and burials, reinforcing the idea that Vinapu was not merely an architectural project, but a sacred space tied to the island's ritual life. In such contexts, extraordinary effort and precision in construction may have been intended to symbolize spiritual authority, ancestral reverence, or the power of local chiefs. Another unresolved question involves the logistics behind the construction itself. Easter Island is famously isolated, and by the time European explorers first arrived in the 18th century, the island had already undergone significant ecological changes, including the loss of most of its large trees. Without abundant timber, transporting multi-ton stone blocks becomes extremely challenging. Some researchers have proposed that ancient Rapa Nui builders used wooden rollers or sledges to move stones across the landscape, while others suggest the use of earthen ramps and carefully coordinated teams pulling with ropes made from plant fibers. Yet even with such methods, aligning massive blocks with the level of precision seen at Vinapu would have required careful measurement and repeated adjustments. Each stone would have needed to be positioned, removed, reshaped, and repositioned until it matched its neighboring blocks perfectly. The patience and technical knowledge required for such work indicate that the builders possessed a sophisticated understanding of stone behavior and structural balance. Theories about possible connections between Polynesia and South America have occasionally resurfaced in discussions about Vinapu. Certain plants, such as the sweet potato, are known to have traveled between the continents long before European contact, suggesting that limited interaction across the Pacific may indeed have occurred. However, no definitive archaeological evidence has yet confirmed direct cultural exchange between the builders of Rapa Nui and the Inca civilization. Most scholars therefore favor the explanation of independent innovation and proposing that similar architectural solutions can arise in different cultures when builders confront comparable engineering challenges. Even so, the visual resemblance between Vinapu's precisely fitted stones and the famed masonry of the Andes remains striking enough to keep the debate alive. Today, Ahu Vinapu stands not only as a ceremonial platform, but also as a testament to the ingenuity of the ancient Rapa Nui people. Its smooth, precisely cut stones continue to raise questions about how prehistoric builders solved complex engineering challenges using limited resources. The remarkable flatness of the stone blocks remains one of the most puzzling aspects of the structure, suggesting advanced techniques of grinding, shaping, and measurement that archaeologists are still trying to understand. And far from being a primitive construction, Vinapu shows that even on one of the most isolated islands on Earth, ancient builders achieved a level of craftsmanship comparable to some of the greatest stone architecture in the ancient world. In your opinion, how were the ancient Rapa Nui able to cut and polish such massive stone blocks so incredibly flat at Ahu Vinapu despite having no metal tools? Share your thoughts or theories in the comments below. Rising from the shallow coral reef off the eastern coast of the island of Pohnpei in Micronesia lies one of the most enigmatic archaeological landscapes ever constructed by human hands, Nan Madol, often called the Stone City of the Pacific. At first glance, the ruins appear almost unreal. Massive walls of dark volcanic stone rising from the sea, narrow canals weaving between artificial islets, and silent structures that seem to float just above the water. Unlike most ancient cities built on stable ground, Nan Madol was constructed directly on a coral reef, forming a complex network of more than 90 small artificial islands connected by tidal waterways. This unusual layout has often led researchers to compare it to a prehistoric Venice of the Pacific. Yet the deeper archaeologists investigate the site, the more it reveals mysteries that challenge our understanding of ancient engineering. Built primarily between the 12th and 17th centuries during the rule of the Sodelur dynasty, Nan Madol served as a ceremonial and political center rather than a typical residential city. Only elites, priests, and rulers were allowed to inhabit its stone compounds, while the general population remained on the main island of Pohnpei. Despite its restricted population, the city required enormous resources to construct, suggesting a highly organized political system capable of mobilizing large labor forces across the island and possibly beyond. However, the most astonishing feature of Nan Madol is not its social structure or even its unique location in the sea. It is the material from which the city itself was built. The walls and foundations of Nan Madol are composed of enormous basalt columns, naturally formed volcanic prisms that resemble gigantic logs of stone. Many of these columns measure several meters in length and can weigh between 5 and 25 tons each. Thousands of them were stacked in alternating layers, creating massive fortress-like walls that in some places rise nearly 10 meters high. These basalt prisms were arranged using a construction technique similar to log cabin architecture, where long stones are placed perpendicular to each other in interlocking patterns to stabilize the structure without the use of mortar. Even after centuries of exposure to ocean winds, salt water, and tropical storms, many of these walls remain standing, and a testament to the remarkable understanding of balance and weight distribution possessed by their builders. Yet the deeper mystery of Nan Madol lies not in how the stones were arranged, but in how they arrived there in the first place. The island of Pohnpei does contain basalt formations in its mountainous interior, but the quarries are located far from the reef where Nan Madol stands. To construct the city, ancient builders would have had to move thousands of these massive stone columns from inland volcanic formations down to the coast, and then somehow transport them across open water to the reef where the artificial islands were being assembled. The scale of this logistical challenge is staggering. Modern estimates suggest that the total weight of basalt used in the city reaches hundreds of thousands of tons. Each individual column is comparable in weight to a small truck. Yet the builders of Nan Madol had no metal cranes, no wheeled vehicles, and no known mechanical lifting systems capable of handling such loads. This raises one of the most perplexing engineering questions in Pacific archaeology. How did a relatively small island society move and position stones of this size in the middle of the ocean. Several scientific hypotheses have been proposed, but none fully resolve the mystery. One possibility is that the basalt columns were transported by large wooden rafts or canoes along the coastline. According to this idea, workers may have dragged the stones down from the mountains using ropes and wooden sledges, then floated them across shallow lagoons during high tide. However, this explanation encounters serious difficulties. And basalt is extremely dense, meaning that many of the columns would have been difficult to float without sophisticated buoyancy techniques. Additionally, maneuvering multi-ton stones across rough coastal waters without modern navigation tools would have required extraordinary precision and coordination. Another theory suggests that the stones were rolled on logs from inland quarries to the shoreline before being transferred onto boats. Yet Pohnpei's rugged terrain, steep slopes, and dense tropical forests would have made such transport extremely challenging. Even if hundreds of workers were involved, moving stones of this size over uneven jungle ground would have been a monumental undertaking. Archaeologists have also proposed that stones may have been moved incrementally along prepared pathways, perhaps using earthen ramps and wooden frameworks to guide them toward the sea. Still, physical evidence for large-scale transport infrastructure remains limited. Because no single explanation fully accounts for the sheer quantity and size of the basalt columns used at Nan Madol, the mystery of their transportation continues to fascinate researchers. In local Pohnpeian oral traditions, the origin of the city is explained through legends rather than engineering. According to one widely known story, Nan Madol was built by two powerful sorcerer brothers who possessed supernatural abilities that allowed them to make the heavy stones rise into the air and move through the sky. With the help of magic and chanting, the stones supposedly flew from distant mountains and settled into place on the reef. While modern archaeology does not interpret these stories literally, such legends illustrate how extraordinary the construction of Nan Madol must have appeared even to later generations of island inhabitants. When a society preserves myths describing stones flying through the air, it often reflects the fact that the real methods used by their ancestors had already been forgotten. Beyond the mystery of stone transport, Nan Madol also raises questions about its foundations. Building massive stone structures on top of a coral reef presents serious stability challenges. Coral substrates are uneven and porous, yet the builders managed to create stable platforms by layering coral rubble, small stones, and sediment to form artificial islands before erecting the basalt walls. Over time, these platforms hardened and settled into surprisingly durable foundations capable of supporting enormous weight. Even today, many of the ruins remain intact despite centuries of tidal erosion and tropical weather. This suggests that the builders possessed a practical understanding of marine construction techniques that is rarely documented in other ancient island cultures. The layout of Nan Madol further emphasizes its ceremonial significance. The city is divided into distinct sectors, including mortuary compounds, ritual spaces, administrative enclosures, and elite residences. The most famous structure within the complex is Nan Duwas, a massive funerary compound believed to contain the tombs of Sodalur rulers. Its towering basalt walls surround an inner courtyard where royal burials once took place, reinforcing the idea that Nan Madol functioned as a sacred political center rather than a densely populated city. For centuries, this stone metropolis stood as the seat of Sodalur power until the dynasty eventually collapsed and the site was gradually abandoned. Jungle vegetation slowly crept over the ruins, and the canals, filled with sediment and mangrove roots. By the time European explorers reached Pohnpei in the 19th century, Nan Madol had already become a silent relic of a forgotten era. Archaeologists continue to study the site, yet the central mystery remains unresolved: how thousands of massive basalt columns were transported across land and sea to build a city on a coral reef. Today, Nan Madol stands not only as a remarkable monument of ancient architecture, but also as a reminder that some achievements of human ingenuity have been lost to time. How do you think ancient builders managed to transport the massive basalt stones to Nan Madol without cranes, wheels, or modern technology? Share your theory and thoughts in the comments below. High above the historic city of Cusco in the Andes Mountains of Peru stands one of the most astonishing architectural achievements of the ancient world: the massive stone walls of Sacsayhuamán. This extraordinary complex, built by the Inca civilization, overlooks the former capital of their vast empire and has fascinated historians, archaeologists, and engineers for centuries. At first glance, Sacsayhuamán appears to be a colossal fortress, its enormous zigzagging walls stretching across the hillside like the spine of some ancient stone creature. But the deeper scholars examine the site, the more it becomes clear that this is not simply a defensive structure. It is a masterpiece of engineering, logistics, and stone craftsmanship that still challenges modern understanding. Despite decades of archaeological study, many aspects of its construction remain unexplained, raising profound questions about the technological capabilities of the Inca and possibly even the cultures that preceded them. The most striking feature of Sacsayhuamán is the sheer scale of its stones. Hundreds of enormous blocks were used to create the towering walls, some of which weigh well over 100 tons. The largest stones are estimated to reach weights of more than 300 tons and stand several meters tall. These megalithic blocks were not simply stacked in crude fashion. Instead, they were carefully shaped and fitted together with astonishing precision. Even more puzzling is the fact that the primary stone quarries used for the construction of Sacsayhuamán were located kilometers away from the site itself. Now, transporting such massive stones across rugged Andean terrain would be a formidable challenge even with modern machinery. Yet the Inca civilization did not use the wheel for heavy transport and had no draft animals comparable to horses or oxen. Scholars have proposed that thousands of laborers may have dragged the stones using ropes, wooden rollers, and earthen ramps, but no definitive archaeological evidence fully confirms these theories. The logistics involved in moving stones of such immense size remain one of the enduring mysteries of the site. Equally remarkable is the design of the walls themselves. Rather than forming straight lines of rectangular blocks, the stones of Sacsayhuamán are cut into irregular polygonal shapes that interlock like a gigantic three-dimensional puzzle. Many of these stones have 10 or even 12 sides, and each one fits perfectly with the surrounding blocks without the use of mortar. The seams between stones are so tight that in many places not even a thin blade can be inserted between them. This technique, known as polygonal masonry, is widely regarded as one of the most sophisticated forms of stone construction ever achieved in the ancient world. The irregular shapes allow the stones to distribute weight evenly and lock together in a way that increases the stability of the structure. This may explain why the walls have survived powerful earthquakes that have destroyed many later buildings in Cusco constructed during the Spanish colonial period. While Spanish structures collapsed during major tremors, the ancient Inca stone walls often remained standing and shifting slightly and then settling back into place without catastrophic failure. This extraordinary seismic resistance suggests a deep understanding of structural dynamics that seems remarkably advanced for its time. The layout of the fortress adds another layer of intrigue. The walls form a series of massive zigzag patterns that stretch across the hillside for hundreds of meters. Some researchers believe this design was purely defensive, creating angles that allowed defenders to attack enemies approaching from multiple directions. Others argue that the zigzagging walls may hold symbolic meaning tied to Inca cosmology and the sacred geography of Cusco. According to some interpretations, the ancient city was intentionally designed in the shape of a puma, a sacred animal in Inca culture, with Sacsayhuamán forming the head of the creature and the zigzag walls representing its teeth. Whether the design served military, symbolic, or ceremonial purposes, or perhaps all three, remains a subject of debate among scholars. Yet among all the mysteries of Sacsayhuamán, one of the most fascinating and difficult to explain involves the marks left behind on the stones themselves. Many of the enormous blocks display surfaces that appear to have been cut, carved, and polished with an extraordinary level of control. Some stones contain sharply defined grooves and channels that run across the rock with surprising straightness. Others show perfectly smooth faces, where the stone appears to have been shaped with meticulous care. In certain areas, the edges between adjoining stones follow complex curves and angles that seem almost impossibly precise when considering the tools believed to have been available to the Inca. Archaeological evidence suggests that the Inca primarily used stone hammers and relatively soft metal tools made of bronze or copper alloys. Such tools are generally considered insufficient for cutting extremely hard stone with the degree of precision visible at Sacsayhuamán. Andesite and limestone, the primary materials used in the walls, are not easily shaped with simple pounding techniques alone. These puzzling surface marks have led to ongoing debate among researchers about how exactly the stones were worked. Some scholars believe the builders relied on a painstaking process of repeated hammering and grinding using harder stone tools combined with abrasive materials such as sand and water. Others propose that the Inca may have developed specialized techniques of stone polishing that have not been fully reconstructed by modern experiments. There are even suggestions that heating and cooling methods might have been used to weaken the rock before shaping it. However, despite numerous attempts to replicate the cutting marks using traditional tools, many experiments have struggled to reproduce the same smooth surfaces and sharply defined angles seen at Sacsayhuamán. This has fueled speculation that the ancient builders possessed stoneworking knowledge that has either been lost or not yet fully understood by modern archaeology. The contrast between different layers of construction at Sacsayhuamán further deepens the mystery. The lowest sections of the walls contain the largest and most precisely fitted megalithic blocks, while higher portions include smaller stones that appear less refined. Some researchers have suggested that this difference may indicate multiple construction phases, possibly involving different groups or technological traditions. According to this view, the earliest builders may have constructed the massive megalithic foundations, with the Inca later expanding or modifying the site. While this theory remains controversial, it reflects the difficulty scholars face when trying to fully explain the extraordinary craftsmanship visible in the lower walls. Even after centuries of observation and decades of research, the walls of Sacsayhuamán continue to challenge our understanding of ancient technology. The enormous stones, perfectly fitted joints, earthquake-resistant design, and mysterious cutting marks reveal a level of engineering mastery that remains difficult to explain. Standing before these towering walls, it is hard not to wonder how a civilization without iron tools, wheeled transport, or modern machines could create such a precise and enduring monument. Today, Sacsayhuamán stands not only as a symbol of the power of the Inca Empire, but also as a reminder that parts of humanity's technological past may still remain unknown. How do you think the Inca were able to cut and fit the enormous stones at Sacsayhuamán with such precision? Share your thoughts or theories in the comments below. The Göbekli Tepe megalithic sanctuary in southeastern Turkey stands as one of the most astonishing archaeological discoveries of the modern era. A site that has profoundly reshaped how historians understand the origins of civilization. Rising from a limestone hill in the region of Şanlıurfa, the sanctuary dates back to roughly the 10th millennium BCE, making it more than 11,000 years old, thousands of years older than the pyramids of Egypt and long predating monuments such as Stonehenge. What makes Göbekli Tepe so extraordinary is not merely its age, but the level of architectural complexity it reveals at a time when human societies were still believed to be primarily small groups of hunter-gatherers. According to traditional models of history, monumental architecture appears only after the development of agriculture, unsettled communities, and hierarchical social structures. Yet Göbekli Tepe challenges that sequence entirely. Here, long before cities, writing, pottery, or metal tools existed, human communities constructed a massive ceremonial complex composed of carefully arranged stone circles, towering pillars, and intricate carvings that suggest a sophisticated symbolic world already flourishing at the dawn of civilization. At the heart of the site are monumental circular enclosures formed by enormous limestone pillars carved into a distinctive T-shape. Some of these pillars reach heights of 5 to 6 meters and weigh between 10 and 20 tons, an astonishing achievement for a culture lacking metal chisels or advanced construction equipment. Now, each enclosure typically features 2 larger central pillars, surrounded by a ring of slightly smaller ones, creating an architectural arrangement that appears deliberate and highly organized. Many researchers interpret the T-shaped pillars as stylized human figures, especially because several of them display carved arms, hands, belts, and loincloths. If this interpretation is correct, the pillars may represent ancestors, spirits, or deities, transforming the entire structure into a kind of monumental gathering place for ritual activity. The stone surfaces themselves are decorated with remarkably detailed carvings of animals: foxes, wild boars, snakes, scorpions, vultures, and other creatures that likely held symbolic significance in the world-view of the people who built the sanctuary. These carvings are executed with a precision and artistic skill that seem extraordinary for such an early period, demonstrating that the builders possessed both technical knowledge and a deep cultural tradition of symbolism. Yet among all the mysteries surrounding Göbekli Tepe, perhaps the most puzzling involves the simple but fundamental question of how the enormous stone pillars were moved and erected in the first place. The limestone used for the pillars was quarried from bedrock located on the same hill, sometimes only a few hundred meters from where the structures now stand. Archaeologists have identified partially carved pillars still lying in ancient quarry pits, revealing that the builders cut these monolithic blocks directly out of the natural stone. However, extracting the stone was only the beginning of the challenge. That once freed from the bedrock, these blocks, some weighing as much as a modern truck, had to be transported across uneven terrain to the construction site and then raised upright with remarkable stability and precision. What makes this task so mysterious is the technological context of the time. Around 10,000 BCE, there is no evidence that humans in the region possessed the wheel, draft animals such as oxen for pulling heavy loads, or sophisticated lifting machinery. Metal tools had not yet been invented, and wooden engineering systems would have been extremely limited in durability and strength. Despite these constraints, the builders somehow managed to coordinate the quarrying, transport, shaping, and placement of dozens of massive pillars, suggesting an engineering process far more complex than previously imagined for prehistoric societies. Several hypotheses have been proposed to explain this feat, but none fully resolves the puzzle. One possibility is that large teams of workers used wooden sledges or rollers combined with ropes made from plant fibers to drag the stones across the landscape. Such methods are known from later ancient civilizations, but even these techniques would require considerable manpower and careful planning. Experiments conducted by archaeologists have shown that moving a multi-ton block with primitive tools could demand the coordinated effort of dozens, perhaps even hundreds, of people working together in precise synchronization. This raises further questions about the social organization of the communities responsible for Göbekli Tepe. The hunter-gatherer groups are generally thought to have been small and mobile, lacking the hierarchical leadership necessary to organize massive labor projects. Yet the construction of multiple large enclosures at the site implies repeated large-scale cooperation over long periods of time. The transportation of the stones therefore hints at the existence of a complex social network, one capable of mobilizing labor, planning construction phases, and transmitting specialized knowledge about stoneworking techniques. Another unsolved aspect involves the final stage of construction, raising the pillars upright. Modern engineers recognize that lifting a 20-ton stone into a vertical position without cranes or metal tools is a formidable challenge, even with contemporary knowledge. And some researchers believe the builders may have dug deep foundation pits and gradually levered the pillars upright using earthen ramps and wooden supports before securing them in place with carefully packed stone and soil. Others suggest that partially completed pillars could have been dragged into position horizontally and then raised using a combination of ramps, ropes, and coordinated pulling by large groups of workers. Yet despite these theories, there is still no definitive archaeological evidence describing exactly how the process was carried out. The engineering knowledge required to successfully execute such operations more than 11 millennia ago remains one of the most fascinating aspects of the site. Beyond its engineering mysteries, Göbekli Tepe also challenges fundamental assumptions about the origins of religion and civilization. The site shows little evidence of permanent housing, cooking areas, or domestic life, suggesting that it may not have been a settlement at all, but rather a ceremonial gathering place, visited periodically by groups from surrounding regions. If this interpretation is correct, the sanctuary might represent one of the earliest large-scale religious centers ever constructed by human beings. In this scenario, ritual gatherings, perhaps involving feasting, storytelling, and symbolic ceremonies, could have brought together communities that were otherwise scattered across the landscape. Some archaeologists have even proposed a radical idea that places like Göbekli Tepe may have played a role in encouraging the development of agriculture. And if large numbers of people regularly gathered at such ritual centers, the need to supply food for these gatherings might have motivated early experiments in cultivation and domestication of plants. In other words, rather than agriculture creating complex societies and monumental architecture, the desire to build and maintain sacred spaces may have helped drive humanity toward agriculture in the first place. Another mystery surrounds the fate of the sanctuary itself. Around 8000 BCE, many of the enclosures at Göbekli Tepe were deliberately buried beneath large amounts of soil and debris. The burial appears intentional and systematic, rather than the result of natural processes such as landslides or erosion. For reasons still unknown, the people who used the sanctuary filled the monumental circles with earth, effectively sealing them away for thousands of years. This act of burial preserved the pillars and carvings in extraordinary condition, allowing modern archaeologists to uncover them millennia later. Yet the motivation behind the burial remains uncertain. It could represent a ritual closing of sacred spaces, a shift in religious beliefs, or a transformation in social organization as agricultural communities became more established in the region. The rediscovery of Göbekli Tepe in the late 20th century, largely through the work of archaeologist Klaus Schmidt, forced scholars to rethink long-standing ideas about early human civilization. The site reveals that monumental architecture, complex symbolism, and large-scale cooperation existed thousands of years earlier than once believed. Among its many mysteries, as the question of how prehistoric builders transported and erected the massive pillars remains one of the most fascinating. Even today, Göbekli Tepe continues to challenge our understanding of humanity's earliest achievements. What do you think is the most convincing explanation for how the massive stone pillars at Göbekli Tepe were transported and raised more than 11,000 years ago? Share your thoughts and theories in the comments below. Rising from the dry landscape of Rajasthan in northern India, the Baori stepwell in the village of Abhaneri stands as one of the most visually striking and technically intriguing water structures ever created in the ancient world. Believed to have been constructed around the 8th or 9th century, traditionally attributed to King Chanda of the Nikumba dynasty, this enormous stepwell was designed to collect and preserve precious water in a region where extreme heat and seasonal drought have shaped human survival for centuries. At first glance, Baori appears almost surreal, like a geometric labyrinth carved into the earth. Yet beyond its dramatic appearance lies a deeper architectural mystery, one that continues to fascinate historians, engineers, and archaeologists who study ancient hydraulic systems and construction techniques. What makes Baori particularly astonishing is not only its size or age, but the extraordinary geometric precision of its design. The stepwell descends roughly 20 meters into the ground, forming a massive inverted pyramid composed of approximately 3,500 narrow stone steps arranged across 13 levels. These steps are not placed randomly or simply for practical descent into the well. Instead, they form an intricate pattern of repeating triangular shapes that stretch across 3 sides of the structure, producing a mesmerizing visual effect that seems almost mathematically perfect. When viewed from above, the entire formation resembles a vast geometric tapestry made from stone, where each line, angle, and intersection aligns with remarkable consistency. The symmetry is so striking that many modern observers initially assume it must have been planned with advanced mathematical calculations or modern surveying equipment. Yet Baori was constructed more than 1,000 years ago, long before the development of modern engineering tools capable of producing such large-scale geometric accuracy. Maintaining this level of precision across such a deep structure presents an extraordinary challenge even by modern construction standards. A small miscalculation in the alignment of steps at the upper levels could easily multiply into significant structural deviation as the construction descended deeper into the ground. However, the steps of Baori maintain an astonishing regularity from the top to the very bottom of the well. The angles between the staircases remain consistent. The spacing between levels stays remarkably uniform, and the visual symmetry of the triangular patterns continues uninterrupted across the entire surface. This suggests that the builders possessed a sophisticated understanding of geometry, spatial planning, and large-scale layout techniques. Scholars continue to debate how such accuracy could have been achieved with the tools available during the early medieval period. Some researchers suggest that highly refined rope and peg measurement systems may have been used to maintain alignment across the massive structure, while others propose that master builders relied on advanced geometric knowledge preserved through architectural traditions that are only partially understood today. The sheer scale of the excavation required to create Chan Baori adds another layer to the mystery. Constructing the stepwell required removing an enormous volume of earth and stone, carving a deep shaft into the ground before lining its walls with precisely fitted stone blocks, capable of resisting the pressure of surrounding soil for centuries. Unlike many modern structures, Chan Baori does not rely heavily on mortar to maintain stability. Instead, carefully cut stones were arranged in a way that allowed the structure to remain stable through gravity, balance, and structural distribution. The fact that the stepwell has survived for more than a millennium with minimal structural collapse is a testament to the skill of its builders. In an environment characterized by intense heat, seasonal monsoon rains, and long periods of dryness, maintaining structural integrity over such a long period would require not only architectural knowledge but also a deep understanding of the geological conditions of the region. Beyond its structural complexity, Chan Baori also demonstrates remarkable environmental engineering. Rajasthan experiences some of the harshest climate conditions in India, with temperatures regularly soaring above 40 degrees Celsius during the summer months. The deep design of the stepwell allowed water to remain accessible even as surface levels dropped during drought seasons. At the same time, the descending terraces and layered staircases created shade throughout much of the structure, significantly reducing evaporation. Interestingly, temperatures at the lower levels of the stepwell can be several degrees cooler than at ground level, effectively creating a naturally cooled environment. This suggests that the architects of Chan Baori were not only skilled in structural engineering, but also deeply knowledgeable about microclimates and thermal behavior within large stone structures. In many ways, the stepwell functioned as both a water reservoir and a passive climate control system, long before the principles of modern environmental architecture were formally understood. The geometric arrangement of the steps may also have served structural purposes beyond aesthetics. The triangular repetition across the walls distributes weight and pressure evenly along the sides of the well, reducing the risk of collapse as the earth surrounding the structure shifts over time. Additionally, the vast network of steps allowed people to access water at any depth depending on seasonal water levels. During monsoon seasons, when the well filled higher, only the upper terraces needed to be used. During extreme droughts, inhabitants could descend dozens of meters along the staircases to reach the remaining water supply. This adaptability made stepwells like Chan Baori essential to the survival of communities across Western India. Yet despite centuries of study, many questions remain unanswered. Why was such an elaborate geometric design chosen for what was essentially a water reservoir? Was the precise symmetry purely aesthetic, or did it hold symbolic or religious meaning within the cultural traditions of the region? Some historians believe that the geometry may have reflected sacred cosmological ideas found in Hindu architectural philosophy, where symmetry and repeating patterns represented harmony between human construction and cosmic order. Others argue that the design was primarily practical, maximizing structural stability and shading efficiency. Without written construction records from the original builders, the true reasoning behind these design choices remains uncertain. Adding another layer of cultural significance to the site is the nearby Harshat Mata Temple, dedicated to the goddess of joy and happiness. The proximity of the temple suggests that Chand Baori was more than just a utilitarian water structure. In ancient Indian society, stepwells often functioned as gathering places, ritual spaces, and social centers where communities met, rested, and performed religious ceremonies. The descent into the cool depths of the stepwell may even have carried symbolic meaning, representing a journey from the harsh heat of the earthly world toward the life-giving water hidden beneath the ground. More than 1,000 years after its construction, Chand Baori still stands as a powerful testament to the ingenuity of ancient Indian engineering. Its striking symmetry and massive scale make it appear less like a simple well and more like a monumental geometric artwork carved into the earth. The perfectly repeating staircases, long-lasting structural stability, and clever environmental design all reveal an impressive level of technical sophistication. Even today, with modern surveying technology and digital engineering tools, and one question remains: how were ancient builders able to achieve such extraordinary geometric precision on such a massive scale? What do you think allowed ancient builders to achieve the almost perfect geometric precision of Chand Baori more than 1,000 years ago? Was it simply skill with primitive tools, or did they possess advanced knowledge that we still do not fully understand today? Share your thoughts in the comments below. Hidden beneath the volcanic landscape of central Anatolia in modern-day Turkey lies one of the most extraordinary underground constructions ever created by human hands: Derinkuyu Underground City. Carved deep into the soft volcanic rock of the Cappadocia region, this vast subterranean complex represents a remarkable feat of ancient engineering, whose full story still remains partially unexplained. Discovered accidentally in 1963, when a local resident knocked down a wall in his home and revealed a mysterious tunnel behind it, the site quickly astonished archaeologists. What initially appeared to be a simple underground passage soon revealed itself to be something far more astonishing: a massive multi-level city descending approximately 85 meters beneath the surface of the Earth. This archaeological exploration has revealed at least 18 separate levels, connected by narrow corridors, stairways, and shafts, forming an intricate labyrinth capable of supporting an entire underground society. Scholars estimate that as many as 20,000 people could have taken refuge within its chambers at the same time, along with livestock, food supplies, and essential living facilities. Even today, only a portion of the complex has been fully explored, leaving open the possibility that the underground network may extend even deeper than currently known. What makes Derinkuyu particularly remarkable is not merely its depth, but the extraordinary sophistication of its internal infrastructure. The city was carved directly into layers of volcanic tuff, a relatively soft rock that can be cut with simple tools, yet remains structurally stable once excavated. Despite this advantage, creating such a massive underground system would still have required enormous planning, organization, and labor. The builders carved living quarters, storage rooms, kitchens, wine presses, chapels, meeting halls, and animal stables, all arranged in a way that allowed the underground community to function for extended periods of time without returning to the surface. Large storage chambers were designed to preserve grain and food, while separate areas were reserved for religious gatherings and education. Some sections even appear to have served as schools or communal meeting rooms. Perhaps most impressive of all is the city's complex ventilation system. More than 50 vertical shafts extend upward through the rock, allowing fresh air to circulate through the deepest levels of the underground settlement. The largest of these shafts descends more than 50 meters and also served as a water well, ensuring that inhabitants could access fresh water even while remaining hidden below ground. Engineers studying the system today have noted that the ventilation design works remarkably well, maintaining airflow throughout the underground levels despite the depth and density of the surrounding rock. The fact that ancient builders could design such an effective ventilation system without modern instruments continues to puzzle researchers. Yet among all the extraordinary features of Derinkuyu, none perhaps the most intriguing and the most mysterious from a defensive engineering perspective are the massive circular stone doors placed throughout the tunnel system. These enormous stone discs represent one of the most sophisticated security mechanisms ever discovered in an ancient underground structure. Each door was carved from solid stone and shaped into a thick circular slab resembling a gigantic millstone. Some of these stones measure more than 1 meter in diameter and can weigh several hundred kilograms. Positioned at key points throughout the city, particularly along narrow corridors and at entrances to deeper levels, these doors were designed to function as powerful barriers against potential invaders. The engineering concept behind them is surprisingly effective. Rather than swinging open like a traditional door, the massive stone discs were designed to roll sideways across the corridor using a carved groove in the floor. Once rolled into place, the stone would completely seal the passageway, blocking any movement forward. A small central hole in the middle of the stone allowed defenders inside the city to observe the other side of the barrier, or possibly use spears through the opening if attackers attempted to break through. What makes these defensive mechanisms especially fascinating is the strategic way they were integrated into the architecture of the tunnels themselves. The corridors in Derinkuyu are deliberately narrow and low in many places, forcing anyone moving through them to slow down and move single file. This design meant that if an invading force attempted to enter the city, defenders could quickly roll the stone door across the passage, sealing the tunnel with a massive obstacle that would be extremely difficult to move from the outside. Because the door sat within a carved recess in the floor and walls, attackers pushing from the outside would have had almost no leverage to shift the stone. Meanwhile, people inside the city could easily roll the stone back using simple leverage. In essence, the entire underground city functioned like a carefully designed defensive maze, where a relatively small number of inhabitants could block off entire sections of the city and isolate intruders. However, these extraordinary stone doors also raise several unanswered technological questions that continue to intrigue archaeologists. The first mystery concerns how such enormous stones were transported and installed deep inside the underground tunnels. Moving a circular stone weighing hundreds of kilograms through narrow passageways would have been extremely challenging, even with modern equipment. Yet the builders of Derinkuyu somehow managed to position these stones precisely within carved recesses along multiple levels of the city. Another question involves the planning required to incorporate these mechanisms during construction. Because the doors were integrated directly into the architecture of the corridors, the builders must have anticipated the need for defensive barriers while the tunnels were still being excavated. This implies a remarkably advanced level of planning and engineering foresight. Beyond the defensive system, Derinkuyu's broader layout suggests that the underground city was designed not merely as a temporary refuge, but as a long-term survival environment. Archaeologists have identified kitchens with smoke-blackened ceilings, wine storage areas, oil presses, communal rooms, and even spaces believed to have served as chapels. Livestock could be kept in separate chambers, preventing contamination of living spaces while still allowing inhabitants to maintain a supply of fresh food. The presence of deep wells that could only be accessed from inside the city suggests that protecting the water supply was a critical concern, reinforcing the idea that residents may have stayed underground for extended periods during times of conflict or invasion. When historical evidence suggests that the city may have been expanded during the Byzantine era, when local populations needed protection from raids and invasions. However, some scholars believe that the earliest parts of the complex may date back much further, possibly to the Phrygians around the 8th century BCE. Another intriguing feature is the possibility that Derinkuyu was not an isolated underground refuge, but part of a much larger subterranean network. In the Cappadocia region, archaeologists have identified more than 200 underground settlements carved into the same volcanic rock formations. Some of these are believed to be connected by long underground tunnels stretching for several kilometers. One such passage may link Derinkuyu to another underground city called Kaymaklı, and if these connections were indeed functional in antiquity, they would represent an extraordinary level of subterranean planning and coordination across an entire region. Despite decades of research, many aspects of Derinkuyu underground city remain unexplained. Scholars still debate how ancient builders excavated such a vast underground complex, removed enormous amounts of stone, and maintained structural stability across multiple levels. The precision of its ventilation system, the careful organization of living spaces, and the ingenious defensive stone doors all suggest a level of engineering knowledge that seems surprisingly advanced for its time. Today, Derinkuyu remains one of the most remarkable underground cities ever discovered and continues to stand as a fascinating archaeological mystery beneath the earth. If an ancient civilization was able to design and build a massive underground city like Derinkuyu, complete with complex ventilation systems and giant defensive stone doors, what kind of engineering knowledge or techniques do you think they might have used? Share your thoughts in the comments below. High in the rugged highlands of northern Ethiopia stands one of the most extraordinary architectural achievements in human history, the remarkable complex known as the Lalibela rock-hewn churches. Carved directly into solid volcanic rock, this sacred landscape appears less like a group of buildings and more like a hidden city that has been sculpted out of the earth itself. Unlike traditional architecture, where stones are quarried, transported, and assembled into walls, the churches of Lalibela were created through a radically different method. Each structure was carved downward into the living rock, meaning that the builders first cut deep trenches into the mountain surface to isolate massive blocks of stone, then slowly excavated downward until roofs, walls, windows, columns, and interior chambers emerged from a single, continuous mass of rock. This top-down method of construction required extraordinary foresight because every element of the structure had to be planned in advance. A single mistake in measurement could have destroyed an entire church before it was even completed. Yet the surviving buildings show remarkably consistent proportions, balanced geometry, and carefully carved details, suggesting that the builders possessed a highly sophisticated understanding of stoneworking and structural design. Most scholars believe the churches were created during the reign of King Lalibela in the 12th and early 13th centuries, when Ethiopia was a powerful Christian kingdom, seeking to establish its own spiritual center after access to Jerusalem became difficult during the Crusades. According to local tradition, the king envisioned a new Jerusalem carved directly into the Ethiopian highlands, a sacred landscape where pilgrims could experience the symbolism of the Holy Land without leaving Africa. The result was an interconnected complex of 11 monolithic churches linked by narrow corridors, deep trenches, and mysterious underground tunnels. From above, the complex resembles a labyrinth carved into the mountain. Some churches stand at the bottom of deep rock courtyards, while others are hidden behind towering stone walls created by the very trenches that were cut to isolate them from the surrounding bedrock. The most famous of these structures is the cross-shaped church known as Beta Georgis, a nearly perfect monolithic building carved more than 12 meters below ground level, its symmetrical form only fully visible from the air. The precision required to carve such a structure from a single rock mass raises profound questions about how medieval builders planned and executed the work without modern surveying tools. Equally mysterious is the vast network of passages and tunnels connecting the churches. Pilgrims walking through Lalibela today often move through narrow stone corridors that twist beneath the ground before emerging into hidden courtyards or sacred chambers. Some passages are dark and constricted, forcing visitors to move slowly through the stone as if retracing an ancient ritual path. Others open into larger spaces that appear deliberately aligned with entrances of neighboring churches. These underground routes may have had symbolic meaning, are representing spiritual journeys or biblical narratives, but they also demonstrate the remarkable engineering knowledge required to excavate complex pathways through solid rock without causing collapse. Carving long tunnels through volcanic stone while maintaining structural stability would have required careful understanding of rock layers, pressure distribution, and geometry. Yet there is little archaeological evidence explaining how these calculations were performed. Among all the mysteries surrounding Lalibela, however, one of the most intriguing lies in the marks left behind on the stone itself. The surfaces of many walls, columns, and carved details preserve traces of the tools used to shape the rock nearly 900 years ago. At first glance, these marks appear ordinary, and the natural result of chisels and hammers striking stone repeatedly over long periods of time. But closer examination reveals something far more puzzling. In many areas, the cut marks are unusually straight, evenly spaced, and strikingly consistent in depth. Some grooves run almost perfectly parallel across large sections of wall, while other surfaces appear smoothed in a way that suggests a level of precision difficult to achieve with simple medieval tools. The rock at Lalibela is a form of volcanic tuff, which, while softer than granite, is still strong enough to resist crude carving methods. Producing the clean lines visible in certain sections would have required tools capable of controlled, repeated strikes with remarkable accuracy. This has led archaeologists and engineers to debate the nature of the tools used by the original builders. Historical evidence suggests that the craftsmen likely worked with iron chisels and stone hammers, technologies that were certainly available in medieval Ethiopia. Yet some of the tool marks appear unusually refined for such equipment. In certain areas, the cuts seem almost mechanical in their regularity, forming patterns that resemble modern stone-cutting techniques more than the irregular chisel marks typically associated with ancient construction. While it is possible that highly skilled artisans achieved this precision through extraordinary craftsmanship, the consistency of the marks across different parts of the complex continues to provoke questions about the methods used. Thus, some researchers speculate that the builders may have employed specialized chisels or multi-point tools designed to shape stone more efficiently. Others suggest that certain surfaces may have been smoothed using abrasive techniques that have not yet been fully understood. Whatever the explanation, the tool marks preserved in Lalibela offer a rare and enigmatic record of a sophisticated stone carving tradition that remains only partially explained by modern scholarship. Another unresolved question concerns the enormous volume of rock that had to be removed to create the complex. Excavating the churches required cutting away vast amounts of stone from the mountain, potentially hundreds of thousands of tons of material. Yet surprisingly little evidence remains of where this stone was deposited. Unlike many ancient quarry sites where discarded rock forms large piles or embankments nearby, the surrounding landscape of Lalibela does not clearly reveal where such debris might have accumulated. This absence has fueled speculation that the removed stone was either reused for other constructions, gradually eroded over centuries, or transported away from the site entirely. Each possibility raises logistical questions about how such operations were managed in a mountainous region with limited transportation infrastructure during the medieval period. Despite centuries of research, Lalibela remains both a sacred site and an engineering mystery. Its churches were not built from separate stones, but carved directly into the earth, shaped as much by the rock removed as by the rock that remains. The precision of the excavation, not the complex underground passages, and especially the unusual tool marks on the stone, suggest a level of technical skill that still challenges modern understanding. For pilgrims, it is a living place of faith, while for archaeologists and engineers, it continues to raise questions about how ancient craftsmen were able to transform an entire mountainside into one of the most extraordinary architectural landscapes in history. In your opinion, how were ancient builders able to carve the entire complex of Lalibela rock-hewn churches with such remarkable precision nearly 1,000 years ago, especially the unusually consistent tool marks left on the stone surfaces? Share your thoughts or theories in the comments below. The Pumapunku megalithic complex, located on the high Andean plateau near Lake Titicaca, stands as one of the most enigmatic architectural achievements attributed to the ancient Tiwanaku civilization. Sitting at an elevation of nearly 3,850 meters above sea level, the site occupies a harsh environment where thin air, intense sunlight, freezing nights, and powerful winds dominate the landscape. Even today, construction at such altitude would pose significant challenges. Yet more than a millennium ago, the builders of Pumapunku managed to create a monumental complex of massive stone blocks whose engineering continues to puzzle researchers. At first glance, the ruins appear chaotic, or a scattered field of colossal stones resting across a stepped platform as if the remains of a once enormous structure had collapsed long ago. However, closer inspection reveals that these stones are not random fragments, but carefully designed architectural components shaped with remarkable planning and astonishing technical control. Many of the blocks are enormous, with some weighing well over 100 tons, and the largest estimated at roughly 130 tons. The sandstone used in parts of the complex likely originated from quarries approximately 10 kilometers away, while the harder andesite stones, those displaying the most intricate shaping, appear to have come from sources near or across Lake Titicaca, possibly more than 90 kilometers from the site. The challenge of transporting such massive stones across mountainous terrain without wheeled vehicles, iron tools, or large draft animals already raises profound questions about logistics and organization. Yet transportation alone does not explain why Pumapunku has fascinated engineers and archaeologists for decades. What truly distinguishes the site is the extraordinary precision with which many of its stones were cut and shaped. Unlike the rough megalithic blocks seen at many ancient monuments, the stones at Pumapunku often exhibit razor-sharp edges, perfectly straight lines, and flat surfaces that appear almost machined. Some of the most iconic examples are the so-called H-shaped blocks, stones carved into complex geometric forms that seem to follow a standardized design template. Each block contains a combination of angles, recessed channels, drilled holes, and perfectly squared corners that appear strikingly uniform across multiple pieces. When these stones are examined side by side, their dimensions show remarkable consistency, suggesting that the builders may have been working according to precise architectural measurements rather than simply shaping each block individually. In many cases, the surfaces meet at nearly perfect right angles, and measurements performed by modern researchers have shown that the deviations from ideal geometry are sometimes only a few millimeters. Such accuracy is astonishing when one considers that the material being carved, andesite, is an extremely hard volcanic rock. Cutting and shaping andesite with simple stone or copper tools would normally produce irregular surfaces and inconsistent edges, and yet many Pumapunku blocks display surfaces so smooth and planar that they resemble pieces shaped by modern industrial techniques. Some channels cut into the stone are narrow and straight, maintaining a constant depth along their entire length. Other sections contain cleanly defined grooves and slots that appear engineered to accept connecting elements. In certain blocks, small cylindrical holes and circular depressions can be observed, features that some researchers compare to drilling marks produced by rotational tools. Although archaeologists generally interpret these features as the result of patient abrasion, using harder stones and sand as grinding material, the regularity and symmetry of the cuts continue to provoke debate about the exact methods that could have produced them. The mystery becomes even more striking when the stones are considered as parts of a larger architectural system. Rather than simply stacking irregular blocks, the builders appear to have designed many pieces so they could interlock through a network of ridges, recesses, and precisely carved joints. These joints allowed the stones to fit together tightly without large quantities of mortar, creating a structural system that distributed weight efficiently and enhanced stability. The H-shaped stones in particular appear capable of connecting with neighboring blocks in multiple orientations, almost like components in a modular architectural framework. This modularity suggests that the builders may have been working from a highly organized construction plan, in which each stone had a specific role within the larger design. Another remarkable feature of the site involves the use of metal clamps embedded in the stone blocks. Many of the stones contain carved recesses shaped like the letter T or I, which once held metal connectors poured into the slots while molten. Chemical analysis of surviving fragments indicates that these clamps were made from copper-based alloys, sometimes containing arsenic or nickel, demonstrating a sophisticated knowledge of metallurgy. The purpose of these clamps was to bind adjacent stones together, preventing shifting and increasing the structural integrity of the construction. The presence of such connectors shows that the engineers responsible for Pumapunku understood not only the importance of precise stone cutting, but also the mechanical advantages of combining stone architecture with metal reinforcement. And despite extensive research, many aspects of Pumapunku remain unclear. The original layout of the complex is difficult to reconstruct because many of its massive blocks were displaced over centuries, possibly by earthquakes, looting, or natural erosion. What remains suggests that Pumapunku was part of a monumental ceremonial platform connected to the nearby center of the Tiwanaku civilization, which flourished between roughly the 5th and 10th centuries. The site likely held religious or cosmological significance, perhaps functioning as a gateway or sacred space within a larger ceremonial landscape. Even if its role was mainly ritual, the engineering required to quarry, transport, carve, and assemble these stones reveals a remarkable understanding of geometry, materials, and structural design. Be compared with other ancient stone monuments, the precision at Pumapunku stands out dramatically. While Inca masonry at sites such as Machu Picchu is famous for tightly fitted stones, those blocks were shaped individually to match each other. At Pumapunku, many stones appear to follow standardized geometric forms, giving the architecture an almost mechanical quality that some describe as resembling early prefabricated construction. Because of this unusual precision, the site often appears in discussions about the limits of ancient engineering knowledge. Although mainstream archaeology attributes these achievements to extraordinary craftsmanship and organized labor, the exact methods used to create such precise cuts in extremely hard stone remain difficult to reproduce today. As a result, the ruins of Pumapunku continue to inspire both scientific research and public fascination. Scattered across the windswept Andes Plateau, its massive stones still stand as powerful evidence that ancient civilizations may have mastered engineering skills far more advanced than we once believed. Do you think the astonishing precision of the stone blocks at Pumapunku was simply the result of extraordinary craftsmanship by the Tiwanaku builders? Or could it suggest the existence of an ancient technology we still do not fully understand? Share your thoughts in the comments below. Perched high in the Andes Mountains of Peru, the Machu Picchu stone complex stands as one of the most extraordinary architectural achievements of the ancient world. Built during the 15th century under the rule of the Inca Empire, the city occupies a dramatic ridge nearly 2,400 meters above sea level, surrounded by steep valleys and mist-covered peaks. From a distance, Machu Picchu appears almost unreal, as if the stone city had grown directly out of the mountain itself. Hundreds of precisely constructed buildings, ceremonial platforms, temples, agricultural terraces, and stairways spread across the landscape in a carefully organized plan that seems perfectly adapted to the natural terrain. And yet what makes Machu Picchu particularly fascinating is not only its breathtaking location, but the remarkable engineering knowledge demonstrated in its construction. Knowledge developed by a civilization that lacked iron tools, the wheel, or mortar-based masonry. Even today, many aspects of its design continue to puzzle historians, engineers, and archaeologists. One of the most striking features of Machu Picchu is the astonishing precision of its stonework. The Inca builders used massive granite blocks that were cut, shaped, and polished so carefully that they fit together with almost unbelievable accuracy. In many walls, the stones interlock in complex polygonal forms, sometimes with 10 or more angles. Yet the joints between them are so tight that even a thin blade cannot easily pass through. This technique, and often referred to as ashlar masonry, allowed the structures to remain stable without the use of mortar. Considering that granite is an extremely hard material and that the Inca did not possess steel cutting tools, the process by which these stones were shaped remains partly mysterious. Some researchers believe that the builders used harder stones as hammer tools, gradually chipping away at the surface and then polishing it with sand and water until a perfect fit was achieved. Others argue that the extraordinary precision suggests a level of craftsmanship and organization far beyond what was once assumed for pre-Columbian societies. Whatever the exact method, the result is a style of construction that appears almost modern in its accuracy. The engineering brilliance of Machu Picchu becomes even more impressive when considering its location in a region prone to earthquakes. The Andes Mountains lie within a tectonically active zone, where powerful seismic events are not uncommon. Despite this, the stone walls of Machu Picchu have survived for more than 5 centuries, with remarkably little structural damage. Scholars have discovered that many of the buildings were deliberately designed to withstand earthquakes. Walls are often slightly inclined inward, and doorways and windows frequently have a trapezoidal shape, making them more stable during shaking. Because the stones are fitted together without mortar, they are able to move slightly during seismic activity and then settle back into place afterward. This flexible form of construction effectively absorbs seismic energy, preventing the catastrophic collapses that might occur in rigid masonry structures. It is an ingenious solution that demonstrates the Inca understanding of the natural forces shaping their mountainous environment. Another question that continues to intrigue researchers concerns the transportation of the enormous stone blocks used in the city's construction. Machu Picchu sits on a narrow mountain ridge surrounded by steep cliffs and deep valleys, making large-scale construction extremely difficult, even with modern machinery. Yet the Inca managed to transport and position stones weighing many tons across rugged terrain without the benefit of wheeled vehicles or large draft animals. Archaeological evidence suggests that most of the granite used at the site was quarried locally. But even moving the stones from nearby quarries to their final positions would have required extraordinary effort and coordination. Some scholars propose that large teams of workers hauled the stones using ropes made from plant fibers, while others suggest that ramps, earthen pathways, and wooden rollers may have assisted the process. Still, the logistics of moving and precisely placing such heavy blocks across steep mountain slopes remain one of the enduring puzzles of Machu Picchu's construction. Equally impressive is the sophisticated system of water management that runs throughout the entire complex. The region surrounding Machu Picchu receives significant rainfall, and building a city on a narrow mountain ridge would normally pose serious risks of erosion and landslides. To solve this problem, the Inca developed an elaborate drainage system integrated directly into the architecture of the site. Beneath many buildings lie layers of stones and gravel that help channel water away from the foundations. Agricultural terraces covering the surrounding slopes also serve a structural purpose, stabilizing the soil while simultaneously creating fertile areas for cultivation. In addition, a carefully designed network of canals and fountains distributes fresh spring water throughout the city. Archaeologists have identified a sequence of stone fountains connected by channels that guide water from a mountain spring through the settlement. Remarkably, parts of this hydraulic system continue to function today, and demonstrating the long-term durability of Inca engineering. Astronomical observation may also have played an important role in the planning of Machu Picchu. Certain structures appear to be aligned with significant solar events, suggesting that the site served as a place where the movement of the heavens could be observed and interpreted. One of the most famous features associated with this idea is the ritual stone known as the Intihuatana, often described as a ceremonial solar marker. During specific times of the year, particularly near the equinoxes, the position of sunlight on the stone changes in ways that may have allowed Inca priests to track seasonal cycles. Similarly, the Temple of the Sun, Machu Picchu, contains windows that align with the sunrise during the winter solstice. indicating that astronomical knowledge influenced both religious and architectural decisions. These alignments hint at a culture deeply attuned to celestial rhythms and the passage of time. Despite these remarkable achievements, perhaps the most intriguing mystery surrounding Machu Picchu is not how it was built, but why it was abandoned. The city is believed to have been constructed during the reign of the Inca Emperor Pachacuti, who expanded the empire across much of western South America. Many historians think Machu Picchu may have served as a royal estate or ceremonial retreat associated with the imperial court. Yet archaeological evidence suggests that the site was occupied for only a relatively short period, perhaps less than a century, before it was mysteriously deserted during the 16th century. And unlike many other Inca cities, Machu Picchu shows little evidence of violent destruction. There are no widespread burn layers, collapsed defensive structures, or clear signs of military conflict that would indicate a dramatic siege or conquest. Instead, the city appears to have been gradually left behind, as if its inhabitants simply walked away. The timing of this abandonment coincides with one of the most turbulent periods in Andean history: the arrival of Spanish conquistadors and the rapid collapse of the Inca Empire. However, an intriguing detail complicates the story. Historical records from the Spanish conquest make no direct mention of Machu Picchu, suggesting that the Europeans may never have discovered the city during the early colonial period. As this absence has led some scholars to propose that the inhabitants may have deliberately abandoned the site before Spanish forces could reach it, possibly relocating to other areas of the Andes as the political structure of the empire disintegrated. Another theory points to the devastating spread of Old World diseases, such as smallpox, which traveled through the Americas ahead of the Spanish armies and caused massive population declines. Epidemics may have disrupted the social and economic networks that sustained remote settlements like Machu Picchu, eventually making it impossible to maintain the community. Other researchers suggest that Machu Picchu's abandonment may have been linked to changes in religious or political authority following the death of its royal patron. In Inca tradition, royal estates were often closely associated with the lineage of a particular ruler. When that ruler died, the estate might gradually lose its significance or resources, leading to its eventual decline. If Machu Picchu functioned primarily as the private domain of Pachacuti or his successors, the shifting power dynamics of the late Inca period may have reduced its strategic importance. Over time, the city may simply have faded from use as new centers of authority emerged elsewhere in the empire. Whatever the true explanation, the disappearance of Machu Picchu's population remains one of the most haunting aspects of its history. Within only a few decades, a thriving mountain city, complete with temples, residences, terraces, and ceremonial spaces, was left empty. Vegetation slowly reclaimed the terraces. Forests crept over the stone walls, and then the once bustling settlement disappeared beneath the dense Andean jungle. For centuries, the city remained largely hidden from the outside world until it was brought to international attention in 1911 by explorer Hiram Bingham. By that time, the silent ruins of Machu Picchu had already become a powerful symbol of the lost grandeur of the Inca civilization. Today, Machu Picchu remains not only a breathtaking archaeological site, but also a powerful historical mystery. Its precise stonework, earthquake-resistant design, advanced water systems, and possible astronomical alignments reveal an impressive level of engineering knowledge. Yet the central question, why such a remarkable city was suddenly abandoned, remains unanswered, and leaving Machu Picchu as one of the most intriguing, unsolved mysteries of the ancient world. What do you think really caused Machu Picchu to be mysteriously abandoned in the 16th century? Disease, the collapse of the Inca Empire, or perhaps another reason we still do not understand? Share your thoughts in the comments below. Rising dramatically above the dense tropical forests of central Sri Lanka, the ancient citadel known as Sigiriya, often referred to as the Lion Rock Fortress, stands as one of the most extraordinary architectural and artistic achievements of the ancient world. The colossal granite monolith towers nearly 200 meters above the surrounding plains, its steep sides appearing almost impossible to climb. Yet more than 15 centuries ago, it became the foundation for a sophisticated royal capital, built during the reign of King Kashyapa in the 5th century. According to historical chronicles, Kashyapa transformed this isolated rock into an impregnable palace city, combining defensive engineering, ceremonial architecture, landscape design, and artistic expression into a single monumental complex. From the jungle floor, Sigiriya appears almost surreal, a massive pillar of stone rising abruptly from the earth. But the true wonder lies not merely in its dramatic natural form, but in the human ingenuity that reshaped it into a functioning fortress and royal residence high above the land below. The challenge of constructing such a complex on the summit of a near-vertical rock remains one of the site's enduring mysteries. Archaeologists believe that thousands of workers must have participated in transporting bricks, timber, water, and other materials up the rock face, yet the exact methods used to accomplish this monumental task remain uncertain. Thus, the absence of clear evidence for large ramp systems or heavy lifting mechanisms leaves researchers wondering how ancient engineers managed the logistical demands of building an entire palace complex atop a natural rock tower. What makes Sigiriya even more fascinating is that it was not simply a fortress perched on a strategic high point. It was carefully integrated into a vast, meticulously planned landscape that stretched across the surrounding plains. The city at the base of the rock was designed according to symmetrical geometric principles rarely seen in such early architectural traditions. A series of gardens unfolds outward from the central axis of the rock, including water gardens, boulder gardens, and terraced gardens arranged with remarkable precision. These gardens were not only decorative, but also served practical and symbolic functions, representing royal control over nature and reflecting sophisticated urban planning concepts that appear far ahead of their time. Within this landscaped environment lies one of the most remarkable technological achievements of the site, an intricate hydraulic system designed to distribute water through pools, canals, and fountains. During the rainy season, some of these fountains still operate today, sending delicate streams of water into the air, just as they did over 1,500 years ago. The persistence of this system suggests that ancient engineers possessed a surprisingly advanced understanding of water pressure, gravity-fed channels, and underground conduits. Approaching the rock itself, as visitors encounter the remains of one of Sigiriya's most dramatic architectural features, the Lion Gate. In ancient times, this entrance was formed by a colossal sculpture of a crouching lion, carved and constructed into the rock face. Travelers would climb a staircase that passed directly through the lion's open mouth before continuing upward toward the palace above. Today, only the massive stone paws remain, yet their scale hints at the enormous size and symbolic power of the original structure. The lion represented royal authority and protection, transforming the ascent to the summit into a theatrical experience designed to reinforce the king's divine status. However, While the architecture and engineering of Sigiriya are impressive, perhaps the most mysterious and artistically captivating feature of the site lies halfway up the western face of the rock along a sheltered gallery where a series of ancient frescoes were painted directly onto the stone surface. These paintings, widely known as the Sigiriya Maidens, portray graceful female figures adorned with elaborate jewelry, delicate garments, and flowers held gently in their hands. They appear to float against a soft background of clouds, creating the impression that they are celestial beings emerging from the sky itself. The elegance of their poses, the subtle expressions on their faces, and the fluid lines of their bodies reveal an astonishing mastery of artistic technique. Yet what truly astonishes historians and scientists alike is the remarkable preservation and technical sophistication of these frescoes. Created more than 1,500 years ago, the colors remain surprisingly vibrant despite centuries of exposure to heat, humidity, and the harsh conditions of a tropical environment. The pigments appear to have been derived from finely processed mineral compounds blended with natural binders, but the precise formula used by the ancient artists remains uncertain. Even more remarkable is the advanced shading technique visible in the paintings, where gentle gradations of color create depth, volume, and lifelike skin tones rarely seen in early South Asian art. The artists appear to have understood complex principles of color layering and surface preparation, applying pigments onto specially prepared plaster that bonded securely with the rock beneath. This allowed the paintings to endure for centuries without significant fading. Weiss scholars have also noted striking similarities between the Sigiriya frescoes and classical fresco traditions known from other ancient civilizations, particularly the Roman world, suggesting either parallel artistic evolution or the possibility of broader cultural influences moving along ancient trade networks. Another fascinating aspect of these paintings is how skillfully they adapt to the curved rock surface on which they were created. Rather than treating the rock as a flat canvas, the artists used the natural contours of the stone to enhance the illusion of movement and depth. Light and shadow interact with the rock face so that the figures appear almost alive, emerging gently from the stone when viewed from certain angles. Some researchers believe that the original gallery may have contained several hundred such paintings, and forming an immense procession of celestial attendants visible from the plains below. Over time, many of these artworks disappeared due to weathering and human activity, but the surviving figures remain among the most celebrated examples of ancient mural painting in Asia. Adjacent to the fresco gallery stands another enigmatic feature known as the mirror wall. This long surface was coated with a special lime plaster and polished so finely that it once reflected images like a mirror. Historical accounts describe how visitors could see their reflections in the wall as they walked along the gallery beneath the paintings. Over the centuries, travelers began carving short inscriptions onto this polished surface, leaving poems, reflections, and comments about the beauty of the women depicted in the frescoes above. These inscriptions date from roughly the 7th to the 11th centuries and represent some of the earliest examples of written Sinhala poetry. They provide a rare glimpse into how ancient visitors perceived Sigiriya, revealing that the frescoes had already become famous works of art centuries after their creation. When viewed as a whole, Sigiriya is not merely a fortress, but a remarkable fusion of architecture, art, engineering, and royal symbolism. The complex was designed not only for defense, but also as a stage of power, where gardens, water systems, sculptures, and frescoes combined to create an impressive royal landscape. Yet despite decades of research, many of Sigiriya's mysteries remain unresolved, and from how materials were transported to the summit to the techniques used to create frescoes that have survived for centuries. After the death of King Kashyapa in the year 495, the palace was quickly abandoned, and the site gradually returned to its earlier role as a Buddhist monastic retreat. Although the palace structures eventually fell into ruin, the gardens, stairways, and frescoes remain as silent witnesses to one of the most astonishing achievements of the ancient world. Today, Sigiriya continues to fascinate researchers and travelers alike, raising questions about the knowledge and skills that allowed people of the 5th century to create such a monumental masterpiece in the jungles of Sri Lanka. Now, how do you think ancient artists managed to create the Sigiriya frescoes with colors that have remained vivid for more than 1,500 years? Share your thoughts in the comments below.